Okay, well, good morning, everybody. Congratulations on having survived orientation week. This is sort of the last bit for those of you who just started. And this is a Marine Conservation Policy Symposium that we have every year at the end of orientation week. And it's the formal presentation of our graduating students of their projects. So we're all really excited to hear it. And it's also the best chance, maybe not the best chance, because I think there's a party after this. At the party house of your president of the outstanding class. But this, at lunch, it was a great opportunity for the new students to hear the breadth and types of things that our students about to graduate are giving, but it's also great opportunity for you to sit down with them over pizza, I guess, to ask them real questions and interact with them. But I'm jumping the gun a bit. I'm supposed to be here introducing our dean, Paul Shepson, who's going to give you a few words of welcome, and we'll go from there.
Okay, I'll be quick. So thank you for having me with you today. I'm really excited about it. This is one of my favorite of all SoMAS events that's sort of celebrating how far you've come in the past year. And I'm always amazed by how much you've achieved and the excitement about the sort of springboard that we expect MCP to be for you. This is not the end of our relationship with you. Sounds like a threat, but it's more of a promise that on average for most of our MCP students, we have a continuing collaborative relationship with you. That varies from person to person, but many of you end up in important positions around the coastal environment, including Long Island. And so when that happens, we look forward to that. Maybe someday we'll be reporting to you and begging you for money and so on. I'll just leave it with congratulations on what you've achieved. It's really exciting. And part of my ongoing education in marine sciences, I'm making some progress and really enjoying that. So congratulations, and I look forward to hearing your talks.
Okay, some of you I met at orientation, and some of you afterwards at Anne's lovely hosting of the rendezvous at her bed and breakfast. And a lot of you, the ones who are finishing, unfortunately, I didn't get a chance to meet you until right now. I was on sabbatical. Actually, maybe some of you were at the MCP Symposium last year. So that was my last hurrah before running off to sabbatical. And now I'm back, and you've gone through this whole year, and I haven't been a part of it, but I'm sure it was a great experience, and I hope to get to know you. And as the dean said, we do try to keep in touch. You may be asked in the future to come and contribute in some way, maybe give a lecture, help someone find an internship, things of that nature. So congratulations to those of you who are finishing, and welcome to the new class. This is exciting because this is the biggest incoming class of MCP students that we've had. And I've been involved in this program since its very start. And I will be seeing most of you, well, I'll be seeing all of you who are coming in, I hope, in MAR 507, Marine Conservation, as well as MAR 557, case planning. We also have the most enormous class of MAR 507 this year. In addition to the MCP students, we have students taking the class from ecology and evolution, from other parts of SoMAS, and from other departments. So we've got a huge room in Challenger this year, and it's going to be a good group. Okay, so I will not hold things up any further. I'm excited to see what you've done. This is also one of my favorite parts of the year. Thanks.
Okay, thanks, Ellen. Most of you know me, but I'm Ann McElroy, for the few of you who maybe haven't met me yet. But it was my privilege to hold the fort for Ellen when she was on sabbatical last year. So I got to interact with you guys a lot. In that very small room we had last year for the classes, but we put our foots down and feet down and got a bigger room for Ellen's classes this semester, which is essential, really important. But let me just reiterate, please don't be strangers as you move on with your careers. You've started a great professional network here. Many of you already had great professional networks, so you share that with the other classes. But it's been a real pleasure seeing you grow over the year. And we're all looking forward to seeing the great things you do with this degree and your future profession. So join the Instagram group, communicate on Facebook, but for sure communicate with us so we know where you are as you move forward. So without further ado, we'll get started, and we're zooming this and recording it, so you have to wear the mic, otherwise no one hears what you're saying. So Abigail Costigan starting out first, and I will pull up.
Okay, hi everybody. I'm Abigail. Thank you for coming today. And my presentation, I'm going to be talking about horseshoe crab spawning habitat selection. So first, I'm going to talk about some of the ecosystem functions that horseshoe crabs play a role in, how people use them, what kind of habitat they use, threats to them, and then the methods of my project, the results, and some policy implications. So horseshoe crabs are really important in the ecosystem. Basically, when there's more horseshoe crabs, biodiversity and biomass goes up as well. So on the left hand of this photo, that's kind of an example from Delaware Bay, which is the epicenter of horseshoe crab population on the East Coast. And then on the other side is Long Island Sound, where there's fewer horseshoe crabs. And as you can see, there's fewer species and fewer of them. And so that one of big reasons is that their eggs are extremely high in fat, and they're a really good resource for a lot of bird species. But they also play a role hosting epibionts and also as bioturbators. By walking around in the muddy bottom of the shore, they resuspend particles. So people use them for a very long time, very different uses. This image is when horseshoe crabs were used for fertilizer. Back in the day, that practice kind of fizzled out in the 80s, was replaced by an artificial fertilizer. But as you can see, this kind of points to really huge historical abundance. But today they're used as bait in the eel and whelk fisheries, and they're also used in the biomedical field. Their blood is extracted, and it's used in a lot of injectables for the limulus amoebocyte lysate, which is used as an endotoxin test. So what habitat do they use? So when they spawn, they come to the shoreline, and it's really risky for them because they're aquatic animals, they have gills. So if they get flipped over or the tide leaves them behind, then they'll die. So the beaches that they choose are really important. So some factors in that are the wave action, the slope of the beach, the grain size of the sand, because that'll play a role in how their eggs develop. And so in my project, I wanted to look at what habitats they select. And a big question we were looking at are how tidal mudflats play a role in that. So tidal mudflats are important juvenile habitat, and they're also important foraging habitat for adults. And they also, break up that wave energy because there's a shallow area before the shore. So, well, why do we care about what habitat horseshoe crabs use? There are some threats in New York. They're harvested for the bait industry in New York, not the biomedical industry. There's 150,000 horseshoe crab limit. They're also really subject to habitat loss. Sea level rise is an issue everywhere, but especially in our area, it's rising faster than in other areas. And also hardened shorelines are a problem, especially in the Peconic Estuary. There's been a big increase in hardened shorelines since Hurricane Sandy. So because homeowners want to protect their property and also, create docks and things like that. So in the Peconic Estuary, there's been a 96% decline since from 1998 to 2019. So how did I go about this? What did we do? So first I looked at GIS, and we looked at shoreline types based on the Environmental Sensitivity Index that was created by the Office of Response and Restoration in NOAA. A major problem with that is that it's from 2009. That was the most recent one. But I originally started by looking at 52 sites and looking at 6 different shoreline types: fine grain sand, coarse grain sand, and then rocky and sandy beaches, and then all of those beaches with tidal mud flats. So when I went out and did the surveys, I followed the total count protocol that Cornell Cooperative Extension uses when they do their horseshoe crab surveys. And horseshoe crabs spawn in the highest numbers during spring tides, which happen on the full and new moon in May, June. And so the surveys I did lasted 3 moon phases, the full and new moon in May, and then the new moon in June. I did 15 total night surveys. I did the night of the full moon and the new moon, and then 2 nights on either side. That's 5. Mental math. And I did like 2 to 3 sites per night. So it was a little bit of a crazy time for me. So these were my final survey sites. There were 14 total. And these are just total counts of how many horseshoe crabs there are. So you can see these are pretty low numbers. So the yellow dots are 0 to 3, and then orange is 3 to 8, and then the red kind of gets higher. So this one site had the most. There was like 76 horseshoe crabs on one night. It was kind of interesting because that was just one night. On subsequent nights, there were like 2 or none. So it's kind of bizarre in that way. But total count can't really tell you that much because you can't really compare it. So I calculated the average spawning index, which is basically how many female crabs there are per meter. And so this is the spawning index. And as you can see, these are really, really low numbers that we're looking at, like 0.000 whatever, or 0.002 for the highest. So this one's 0.002. So all of these are really low numbers, but you can compare them. And that's indicative of the Peconic Bay, but also these areas weren't really necessarily high horseshoe, like known sites for horseshoe crabs. They were more areas where I kind of went to see what's going on. So yeah, so pretty low over here. Basically, these maps are really zoomed in of the Peconic Estuary, and we're kind of going east. Pretty low in the Great Bay. Low here, you have a little bit of a hot spot over there. And then going farther east, this one site. But the total count on this site was pretty low. It was just a really small beach because it's kind of boxed in because of shoreline hardening. So I thought that was interesting. But those were just my sites. So thankfully, there's this whole network of horseshoe crab monitoring in New York. And they've been collecting data on horseshoe crabs for a very long time. So I used some of their data, and I compared. I made the average of the past 3 years, and looked at their shoreline types and their spawning indexes to see if there was any implications for tidal mudflats. And when I looked at everything, it seemed like there was a preference for tidal mudflats. But when we kind of broke it down, so these are of all of the spawning horseshoe crab locations in Long Island. And there is a preference for like fine medium sand with the exposed tidal mud flat, and then kind of the marsh and tidal flat, but coarse sand wins out. And these breakdowns, you'll kind of see there's a big difference between the different areas. So within the Peconic Basin, this is just my data that I collected. And then over there, that's including data that Cornell collected. And so at first you kind of see a preference for sand and gravel tidal flats, but then that kind of goes away when you add it in. But also if you look at these numbers, like they're both really low, but mine are even lower. So there's really low spawning density. And then the South Shore versus the North Shore was kind of more interesting because they're very different. The South Shore is sandier and the North Shore is rocky. There's no marsh, there's much more marsh habitat on the North Shore that they look at. So for the North Shore, there kind of was a preference for the tidal mud flats, but that went away in the South Shore. So why is that? Well, it's really important to look at sub-regional differences in horseshoe crab habitat use and spawning. For example, like the North Shore and the South Shore, they have really different tidal amplitudes. The tide comes in a lot faster in the North Shore versus the South Shore, and the South Shore is more sloping, so it's kind of an easier place for them to spawn. They can let their guard down a little bit. And the index of spawning levels are really different. It's a lot higher in the North Shore and the South Shore than in the Peconic Estuary. But so if I were to continue on this project, I would want to update the maps that I use, the initial GIS layer, because it's from 2009 and beaches are pretty dynamic, and do more research on horseshoe crabs and what they need. So some policy implications. Recently this year, there were some changes in harvesting regulations. They changed the rules. You can't take them while they're connected and spawning. You can't take them. They did some more lunar closures, but there needs to be more research done, and also I think more fine scale rules on that, because all of New York is managed as one unit, but there's differences within the embayments. And for example, the South Shore, they come to spawn earlier there because it's a little bit warmer versus the North Shore, and so there's a higher harvesting pressure there. And also in the beginning of the season, you can take more crabs per night, so that kind of adds pressure to the South Shore. Yeah, and so in the Peconics, hardened shorelines are a really big issue. So horseshoe crab habitat use should be studied further before they allow more permitting for increasing hardened shorelines. And I want to say thank you to everybody who volunteered and went out with me, because I couldn't have done it without you guys. Some of you are more willing than others, some of you kind of peer pressured into that, but thank you, and also my advisors and the Peconic Estuary Partnership. And then any questions? Yeah.
So is there any historical data on Peconic horseshoe crab spawning abundance that you can compare your data with?
Yeah, more anecdotal, I would say. In general, there's not that much. Like when they were used as fertilizer, they weren't in the counting. And in general, horseshoe crab population levels are kind of understudied.
Yeah, it just seems like Peconics, it's in worse shape than the other areas by far. And it'd be good to understand why.
Yeah.
So.
Yeah.
How many spawning years do females get?
That's a good question. They reach maturity around 12, and they can live to at least 20. So they'd be spawning all those years. It's 8.
And are they allowed to catch more early in the season?
So when it reaches like halfway to the quota, then they can take fewer per night. I think it drops from 200 per night to 100 per night. So yeah.
So they can kill them before they spawn.
Yeah, or like when they're first coming up. And then females can, they spawn multiple times per cycle, so
Unless they're dead.
unless they're dead, yeah.
Abigail, do you know how many permits are given?
That's a really good question. I don't know, unfortunately. I do know that in Connecticut, there's like 2 or 3 or 4, like very, very few, not the same. But I don't know in New York, no, that's a good question.
I mean, they could control it that way, but that's probably very unpopular.
Yeah.
Do the towns involved in the regulation, because I know that the town of Brookhaven, where we live, obviously bushcraft is prohibited during the mating season, and that was a result of pressure from people in the school. Right?
Right, yeah, I know that there's other beaches in towns that have those regulations, but I don't really know. That's a good question because, yeah, the more local policy can make a really big difference.
Is there a certain percentage of like the populations that they're allowed to be harvesting?
It's just based on numbers, so it's not a percentage of the population.
Okay.
It's 150,000 in New York.
Okay, so even though populations would be, I'm assuming shrinking like everything else in the world, but so that hasn't necessarily been representative of what is like, the policy hasn't been representative of
The population. No, and also in New York, the population is declining, you're right, it's considered poor status by the Atlantic States Marine Fisheries Council, so yeah, it's declining.
Do we know about sort of the efficiency of reporting? How do you know that people actually report their harvesting?
Yeah, I think that's based on users, because also it's all at night. I don't know the levels of the difference between what's reported and what's harvested. But yeah, Matt, do you know?
No, I didn't get Paul's question.
Oh,
Sorry.
okay.
I might know, but what was the question?
He asked about the difference between what's reported and what's actually taken by harvesters.
It's it's an honor system, so it can vary.
The amount of
I'll leave it
honor?
at that. Yeah, so I'm sure there's some variability. The state is allowed like about twice that amount to harvest annually, and so they reduce it to 150,000 by half to probably account for some of that sluggish as well, and to help be more conservative. So that's not the estimate. They said.
I know that a lot of places that they are only fishing, as a it's a case, or
No, in New York, it's males and females. Yeah, like Delaware Bay is male only. And then they take more, but they have a higher population. So that would be, yeah, something to consider.
but they have to set up the sex ratio for the catch, half and half, or they have a certain limitation.
I don't think there's a sex ratio right now. They, just this year, I know that they set size limit. So the largest females, can't be taken anymore, but yeah, not in New York, you can take down females. Yeah.
So is the main issue for their population over harvesting? Or is it like reducing good breeding grounds?
Yeah, in New York, it's habitat loss and I think over harvesting. But yeah, habitat loss is a really big problem and it's a big problem for more species as well. So it's kind of harder to fight though, I think, or like think about, yeah.
So along that same lines, is there anything from your data that you can talk about? The shoreline harvest is a real issue, because that's a major habitat loss for the island and species. Is there anything from your data that you can use to work with town
I think so. I think that there's at least some clues on what are more important places, and sharing that with towns could be beneficial, especially like, you know, when the zoning board's meeting and making those decisions.
Okay, last question we're gonna give to the
Zoom.
the
yeah,
head
sorry,
of
Zoom.
the Peconic Estuary Partnership who funded this project, Joyce Novak.
So I think she actually made a comment. Do you want me to read it out for you?
Okay, yeah, okay.
So it's an amazing job, Abigail. This extremely important research will be used to assist the Peconic Estuary Partnership, the Cornell Cooperative Extension, the East End Towns, and New York State in formulating the shoreline preservation strategy focused on horseshoe crab conservation and increasing this species in the Peconics.
Thank you, Joyce.
Great. On that very positive note, we're gonna move on to our second speaker, Keriann Tenney, who fortunately couldn't be here with us today because she got a positive COVID test a couple days ago.
Thank you so much.
Thanks. Gonna share screens and let her present.
Yeah, Keriann, you should be able to share your screen, turn your camera on, and unmute yourself. We see your
Okay.
screen, so.
Perfect. Okay, you can hear me?
Oh,
We're done.
Great job.
Let's start at the beginning. Keriann.
Oh, geez.
Yeah, and we can't quite hear you that well. If you can try and get either closer to your microphone or speak up a little bit.
Okay, can you hear me now?
Not much. Try one more time.
What about now?
Super quiet, Keriann.
I have to turn up her input volume.
Yeah, that's what I just did. Oh, she might have to.
Right.
You might have to look on your microphone.
Crestron speakers.
I think so. It was working earlier.
Oh, okay.
I tried YouTube through it and it was working fine, and I tried it. Oh, is that better?
Try now.
Try again, Keriann. I do.
Hello?
Yep, it was our side.
Okay, let me share my screen again.
Thank you.
It used to be the top choice. They switched it 4 weeks ago.
Thank you, Jackie.
Okay. Just 1 second.
The joys of technology, right?
Just optimizing everything. Okay. Oh, no. Okay, you can see my screen now?
Yes.
Okay, awesome.
Slide mode. Slideshow.
Yes, yep. All right.
Right.
Okay, so I'm Keriann Tenney, and I'll be presenting best practices for marine conservation education, Long Island Marine Debris Outreach. So I interned at the Atlantic Marine Conservation Society, or AMSES for short. AMSES is a non-for-profit organization started in 2016 dedicated to marine conservation through action. They responded to any sick, injured, or deceased marine mammal or sea turtle that strands in New York waters. They also respond to entangled cetaceans and sea turtles. AMSES also conducts seal health assessments, deploy satellite tags, and conduct surveys tracking the movements and population size of seals around Long Island. AMSES also has a critical care facility for cold-stunned sea turtles. They received 20 sea turtles in December that were found cold-stunned in the Massachusetts Cape Cod area. So I was their education intern at AMSES. I attended many beach cleanups at Halleck State Preserve and a few at Jones Beach. At cleanups, I assisted AMSES in informing people about the organization and safety protocols when out on the beach. This was also a great opportunity to talk to people about marine conservation and answering any questions that they may have. Next, I was able to attend a few stranding responses So the picture on the bottom left is the first response I went on. It was of an adult bottlenose dolphin that stranded in Sailor's Haven. During these responses, I got to experience what is involved in processing animals of this size to determine a cause of death, which is important information when we're linking human activities to marine species mortality. I also attended the Makers Fair and the U.S. Coast Guard open house, where I was able to talk to people about AMSIs and issues facing marine life here on Long Island. I also assisted on a few lectures and had the opportunity to assist in the critical care of 8 Kemp's Ridley sea turtles that were left from the ones that they received back in December. So I was able to help prepare food for them, feed them, assist in giving medication, and assist in the process of tagging and getting final measurements before we released them. So taking a lot of the information and experiences I had at AMSI's, I wanted to incorporate my work there with my current job. So I work for the Family Residence and Essential Enterprise Incorporation. It's also known as FREE. FREE follows state mandates to serve and support adults with disabilities. They support more than 4,000 individuals with intellectual, developmental disabilities, mental illness, and traumatic brain injuries. It's FREE's mission to help people of all abilities reach their full potential and thrive in their communities. I've worked for FREE for just about a year and a half now in the Theater Arts Day Habilitation Program as a direct support professional. And it's my responsibility to facilitate educational lessons, provide recreational opportunities, and develop skills for independent living. So my project focused on creating 3 educational events based on my experiences at FREE and at AMSI's. So I planned a beach cleanup at Jones Beach, Field 6. Unfortunately, the beach cleanup did occur during one of the many heat waves we experienced during the summer. So a lot of the individuals that I approached to go to this event were weary of the weather, and I ended up only taking 3 gentlemen with me. And the 3 that I took were very engaged and interested in this activity. They're like most of us, I'd rather be out and about than stuck in a classroom all day. So after the cleanup was over, I actually brought back the 4 pounds of trash that we collected in the hour we spent at the beach. I brought it back to program where I sorted it into mason jars and then used those mason jars in a lecture that I led about different marine species or marine mammals and sea turtles that we see here in Long Island. And then I discussed how these items or what items were collected and how these items can cause issues for different marine species. I gave this same lecture over Zoom, and I found that Zoom was not very effective in engaging the individuals about marine conservation. There were a few technical issues that day. There usually is when we're doing Zoom, and it was very hard to engage them in conversation. I, as the host, control who can unmute when, so it's very difficult to get them involved in talking when I'm trying to lead a lecture and then also get them to interact with me. And a lot of them end up signing on to Zoom and then walking away from their screen. It happens all the time. But the in-person lecture, I actually surprisingly found that a lot of them were very engaged in it, and I was able to get a larger group engaged in learning about marine conservation. So I just want to go over what my project really focused on, which was marine debris. Marine debris is any persistent solid material that is manufactured and disposed of or abandoned in the marine environment, and it can enter the environment directly, indirectly, intentionally, or unintentionally. Most common and harmful types of marine pollution include plastic, cigarette butts, plastic bags, food wrappers, and derelict fishing gear. And the size can range from very small microplastics to abandoned vessels. And our trash has been found in every corner of the ocean, from the most remote shorelines to the Arctics and even the deepest parts of the sea. So it is truly a global issue. So there are two major impacts of marine debris interacting with marine mammals, including ingestion of marine debris and entanglements. Marine debris can be ingested due to mistaken identity. Plastic bags are often consumed by turtles because plastic bags mimic the look and movements of jellyfish in the water, which is a common prey item. Marine debris can also be consumed incidentally when animals are feeding on prey. So for example, a humpback whale that's feeding near the surface, gulping gallons of water into its mouth, can't really pick and choose what's entering its mouth. So since it's feeding at the surface, more common where all this debris is usually found, it's very common that the animal is going to consume that debris. Animals can also become caught in marine debris when swimming in the water column or by the surface, known as entanglements. And most animals get entangled in derelict fishing gear. Marine debris can cause animals to have difficulty swimming and feeding because it slows them down. It can cut into their bodies, potentially leading to amputations or death. And looking at these pictures here, this is the bottom right. I hope you can see my pointer, but the bottom, left here is an example of what a plastic bag can look like underneath or in the water. Very deceiving. And then this is actually a Rizzo's dolphin that AMSES responded to, not this season, is one of the past seasons. And it's hard to tell in the picture, but it is quite skinny. This area on its midsection here is supposed to be more rounded and plump, but this animal was found to have plastic bags within its stomach, which was the cause of death, they determined. This picture on the right here is of a humpback whale that was found to be entangled in thousands of pounds of fishing gear. So the left photo here is what the animal looked like from the surface, and the right photo is what the animal looked like. It's an illustration from underneath the water. And it took days, but AMSES and along with other groups were able to disentangle this particular animal, and it was seen a year later looking pretty healthy. So that was a success story. Going back to just ingestion, ingestion of marine debris can cause gastrointestinal perforation, blockages, and a false sense of satiation, which is what happened to this Rizzo's dolphin, where it felt full, even though it had basically a stomach full of garbage. So it thought it was full, but it didn't have any nutrients within its stomach. So I did do some data analysis on ANSES beach cleanup data. So the graph looks at the total weight collected per month at beach cleanups at Halleck in years 2021 and 2022. I used these years because AMSES had the most data available for me to analyze on those 2 years. And then Halleck also, they host cleanups at Halleck once a week. So there's a lot of data available for me to use. So looking at the graph, just gonna highlight April here. April appears to have a significantly higher amount of total weight collected throughout the month. This could be indicative of greater amounts of trash on beaches near major holidays such as Easter. However, after looking at the data closer, I realized that April had 5 cleanups happen in that month, which was more than other months, as well as at least 10 more data sheets that was recorded compared to the other months, which brings up the question, what is truly impacting the amount of trash being collected? Is it the time of year or the number of people at cleanups? So since I found so many variabilities when comparing the total weight collected at cleanups, I decided to look at the composition of items found on beaches during these cleanups each month. So looking at this graph, you may notice that the items collected in April, which is, this one right here, the second or third bar, is mostly, and as well as all the other months, is mostly food wrappers, which is this green color. It's small pieces of plastic around the microplastic range, which is around 5 millimeters or less, and smaller in size. And then also bottle caps and lids, which is this yellow color. these items don't weigh a lot, and they're the items that are found the most. So that was one of the issues where I found looking at just total weight collected might be harder to do, and really looking at composition of what's being collected might be a better method of determining, what's being seen on our bases, on our beaches, and how that's impacting our environment. Another important thing to mention on this graph here, you can see in this orange color, balloons are being collected every month on the beach in Halleck. This is just year 2021 that I focused on. 2022 had similar results where it was mostly food wrappers, microplastics, and bottle caps, as well as balloons being collected. So that's just something to keep in mind for the future, just being able to track, how many balloons are ending up on our beaches. So plastic bags and the plastic bag and plastic straw ban that happened in 2021, AMSES actually was able to use their data from their beach cleanups to support the passing of those bans. And that brings into question, if we continue to do these cleanups, how can we support other plastic bans to occur to help try and reduce what's entering our beaches or our water. So I also think that this data can be used to bring more awareness to this issue, especially in creating educational signage that can be posted either at beaches or that AMSES could use at their educational events. I wanted to do educational signage, but I ended up not having the time to do it. I did, or I was able to compile a list of articles that another intern that picks up this project after me can use to create the signage that has a lot of good information about the debris that is most commonly found. And just as a little final note on marine debris, I think it's important that we move away from using single-use plastics as best we can, using reusable water bottles, which I know I'm talking to the choir here. I know you guys know this and probably do this most, using reusable shopping bags and straws, just being conscious of how we're disposing of our trash and getting more people involved in beach cleanups and spreading the word to friends and family of how to best spread the word of this issue. So just to kind of close this off, I figured I mentioned my next steps and the next steps for AMSES. So for AMSES, after I presented my project to them last week, and we discussed how to improve their data sheet would be to add the number of participants that come to beach cleanups to the master sheet, because it kind of could reduce the variabilities in their data. So let's say 100 people come to a cleanup and 100 pounds of trash is collected. You can assume that each person collected a pound. So it kind of limits the variabilities in that data. And then I also discussed with them exploring new projects for them where they look to see how accessible beaches are to people. Do they have the proper equipment like wheelchairs and properly sized doors, no steps, ramps, for people of all abilities to be able to enjoy the beach and get involved. And then I also suggested that they create new lectures that focus more on how marine debris impacts marine life, specifically the marine debris that we're finding on our shoreline. And then for my role in FREE, so I'm going to be stepping into a new position as a senior habilitation specialist with a focus on education. So I will be exploring new educational experiences and activities for the individuals I support. And I also plan to continue to work with AMSES in the future for more cleanups, as well as other educational opportunities. I wanted to do more cleanups over the summer, but due to the heat waves that we were experiencing, I deemed it a little unsafe. So I just did the one. I'm hoping in the fall when it's less warm that I can take them out more. And with that, why aren't you? Okay, I don't know why I wasn't going, but that was my work cited. Thank you. And any questions?
relate to me or use a mic.
Oh,
Or was that not a question?
I do have a question. Yeah, I'm interested in the April peak and the
Yeah.
comment how much is collected depends on how many sort of person days worth of cleanup there are.
Mhm.
That implies that when you have beach cleanups, the work is not complete.
Yeah.
I'm wondering how far, sort of how far we are away from having a frequency of cleanups that would keep up with sort of the need, so that plot of frequency, weight versus month would simply reflect the amount of trash that is effectively dumped into the marine environment. Now, how far away are we from the need?
That's a very fair point to pull out. I don't know. From my experience, what I saw over the summer, Halleck is pretty maintained. Their beaches, I didn't see a ton of trash when I was on it, compared to, say, Jones Beach, which has much more highly populated. People are less concerned about throwing cigarette butts where they shall. Yeah, so I just felt like I collected a lot more at Jones. I also, the week after I did my beach cleanup, which I was only there an hour, I only took a few people with me, and we only collected 4 pounds. The week after, I was back there at the same field with a larger group. It was like 20 people. They collected over 40 pounds of garbage. So I think that's where it also suggests like how many people we have versus when we're also doing these cleanups. Obviously, during times when beaches are more populated, we're going to see more garbage. And also, if we have more people picking up, depending on the beach, I feel like that's when we're going to see more collected. But again, most of the items that are being collected are very lightweight. So I don't know if looking at total weight is the best method. I don't know if I answered the question. I hope I did.
Thank you.
We have another question. Hang on one second.
So I guess my question is, you said that the more populated areas of beaches would probably have more trash. I've done a few of the beach cleanups with AMCs with Stony Brook Athletics, and we found that a lot of trash, I think we had the highest recorded cleanup and weight, was because we went not on the beach side where the people walked, but we kind of walked on the back side of West Meadow, where the marshes were. So have you looked into like the areas where the current brings trash, or maybe suggest that to AMCs to go where it's less traveled?
That is a good point. I didn't look into that. I know AMZ's wants or is trying to look at how much trash we're receiving from actually Connecticut. So on the North Shoreline in Halleck, a lot of the trash that we're finding is actually being brought in from Connecticut. So I guess in that sense, being open with even our neighboring states about, the trash issue and maybe getting them involved in trying to do their own cleanup so that we can all, like as a group, limit what trash is being traveled around. That is an interesting point. It is important to follow where the currents are, but also no one at ANSI's are oceanographers, so I don't think they know. They would have to do more research into finding where the currents are actually leading to determine where the trash is going.
Okay, we should.
Just a quick
Okay.
one from me. I want to commend you on working with, an unusual group for us to be involved with, people with intellectual and developmental disabilities. And I see that you've got 4,000 individuals who are being benefited within this pre-organization. So I think that's great. What I also think is that you are learning through this project. You've learned through this project and probably through the work you'll continue to do about the best techniques for educating this group and also activating this group to actually be full participants in conservation. So anyway, not really a question, more a comment. Congratulations.
Thank you. Yeah, and I actually did try to figure out a way to measure their understanding and views on marine conservation through a questionnaire, but the way that they were answering the questions, they were kind of flip-flopping every time I gave it to them. So I determined that that wasn't the best way to assess how they are responding to what I was teaching them. It's best to just look at engagement and see how excited they are, how involved they are in what I'm teaching them as an assessment.
Great. Well, thank you, everybody. And getting further behind, totally my fault. I get wrapped up in this stuff. I'm not a very good gatekeeper. We'll hold further questions till lunch. By the way, you're all invited to lunch, which will show up
No more questions?
before the end. On Desk Talk, I'm gonna turn the mic over to Stella, who's gonna talk about her Antarctic ambassadorship.
Hi everyone, those who don't know me, I am Stella, and those who do, hi. So yeah, I'll be talking about my road to Antarctic ambassadorship. So I did my internship with the International Association of Antarctic Tour Operators, also known as IATO. They are a nonprofit organization that was founded in 1991, and their goal is to advocate and promote the practice of safe and environmentally sound travel to Antarctica. They are a self-regulating trade organization, and they establish extensive procedures and guidelines for things like wildlife watching, site-specific and activity guidelines, as well as regulations and restrictions, and a lot more. And these are then provided to their operators, their members, which can include ship operators, land-based operators, travel agents, etc. And that really helps to ensure that they are promoting safe travel. So within IATO, there are Antarctic ambassadors, and these are people who oftentimes have visited down south, and they come back and they're moved and motivated to make changes to their everyday lives in order to support and promote the conservation of these really unique places. So with that collaboration, they created the definition of an Antarctic ambassador. And this entails someone who loves and respects the region. They educate others by sharing their experiences. They advocate for Antarctica when opportunities arise, and they protect Antarctica by making positive changes at home. So you don't have to have traveled to Antarctica in order to consider yourself an ambassador. I have not traveled, and I very deeply consider myself an ambassador. So for my project, I took the P, protect Antarctica by making positive changes at home, and I kind of worked my internship around that and did a couple of projects based on that one. So before I talk about what I did, I just want to touch upon the importance of science communication. So there's many challenges that you can encounter while communicating your science, but one of the ones I'm going to focus on is people not engaging with their audience. So I'm sure many of you have either sat in a lecture or read a scientific paper and you just find yourself like not retaining anything. So it's really important to know your audience and kind of mold your material for that specific audience. And something else you should do is move beyond the standard deficit model. And the definition of this is that they assume there's a gap between scientists and the public, simply because there's a lack of information on the public side. So this method is deemed condescending and outdated because it's more so a scientist talking at people instead of with and conversing and really trying to understand what they like, what they don't like, what they understand, what they don't understand. So the method I implemented was the community-based research, or CBR method. And so this method works to bring together communities and individuals to solve problems, and therefore they're actively contributing to these positive changes. So this really allows for the engagement of communities on scientific issues that are of interest to them. all while actively answering those questions they may have, improving their understanding of science personally, as well as encouraging the improvement of society and its environments and marine environments and ecosystems. So the first project I worked on was the Beach Cleanup Bingo Card. This was released on June 8th, 2022, which is also World Oceans Day. It was released as part of the Ambassadors projects and joint Clean Seas work with IATO's northern counterpart, the Association of the Arctic Expedition Cruise Operators, also known as IECO. And this downloadable card is available on both IATO's and IECO's website. So what this card does is actively encourages its users to venture to their local beaches or coastlines and pick up any debris they may find. I can refer to Carrie's back on this one, but all of the squares are things that are most commonly found on beaches, and that are also safe to be picked up since this card is targeted for both children and adults. And I also wrote 2 accompanying how-to guides. Again, one is for children and then one is for adults. And this just encourages people more to host their own beach cleanup cards, beach cleanups, and just tells them how to go about doing so if they don't know already. And then I also had a hand in creating the Ambassadorship Challenge card, which was released in June 2022. So each square has a different challenge and it encourages its users to implement positive changes to their lifestyle that will benefit themselves and our planet. Its intent is so that users will utilize this resource to engage in a kind of friendly challenge with friends and family, and who doesn't love a challenge and who doesn't love to win. So among some of the tasks are share sustainability tips with a friend, say no to plastic cutlery and bottles, swap usable bags, and etc. And each of these challenges work for a common goal of educating the public on how to do their part and help the planet and its marine ecosystems. Alongside of that card, I created a blog series. So within a blog series, there are 8 blogs that support the challenge, and each aligns to a specific challenge. So for example, the Say No to Plastic Cutlery and Bottles challenge, I wrote a blog titled Break Free of Harmful Plastics and Be Part of the Solution to the Plastic Problem. Each blog is roughly 500 to 750 words, and it contains facts, shocking science, and helpful tips. So what I was really careful about doing while making these blogs is steering clear of any unnecessary jargon. And if I did have to use it, I thoroughly explained what it was for its users that may not know what it is. And then I had some other couple side projects, create social media captions pertaining to the blogs, guides, and challenges. And then I created a fun interactive quiz titled Which Antarctic Wildlife Are You? And this is basically you answer some questions about your personality, like what's your favorite food, stuff like that. And it'll link you back to either like a blue whale, or there's krill, or a leopard seal, and it just has a fun blurb about that animal. And then I'm currently in the midst of creating a leaflet which surrounds the topic of responsible photography in the Antarctic. And this just ensures that you're taking pictures safely and letting people know the do's and don'ts of taking pictures, and so you're safe and you're not disturbing any wildlife. So an important part in gauging your effectiveness with social media is to look at the number of engagement encounters and clicks and likes and all of that. So these are some of the projects I worked on. So on the first day of the Ambassadorship Challenge card, there were 331 downloads. Since its creation of the Beach Cleanup Bingo card, there were 472 downloads. And through that expansion, the card has piqued a regional Cub Scout group in New Zealand's interest. So this Cub Scout group will now be including this as part of their program to encourage Cub Scouts across New Zealand to make contributions through education and advocacy. And the blog, the first one was 939 views and the second one was 307. However, the website can only generate the amount of views through clicking the redirected links within the blog. So it's probably a little bit more than what it shows. And then overall, the content that was released on Antarctic Ambassadorship Day across all social media, so Twitter, Facebook, Instagram, got almost 100,000 views, which is the highest since its online presence. So just looking at the broader significance with issues regarding climate change and plastic pollution on the rise, public outreach and science communication are really crucial in educating the current and coming generations. Personally, I'm a firm believer that people are more likely to act on a solution and be part of a change if they're properly educated about what it's doing to our environments, which is what really kind of motivated me to create the blogs and create the cards and have a hand in all of that. With the arts and science collaboration for the challenge cards, it allows for a more creative output, one that will hopefully be a little bit more effective in reaching the audience and encouraging them to make these changes. And again, the blog and challenges cards are digestible, interactive, and educational. And to just wrap it up, I really hope that, having my hand in this and having released some of these things, it encourages people to make a change, be the change. And one person is all it takes for everyone. Thank you.
Are we really doing no questions there?
No, we can do some questions.
Yeah, so first, I want to mention that you worked with Gina Greer, right?
I do, yes.
So Gina is a graduate of our FCP program, and she is the executive director of IAATL. So I think it's, it's an important thing for you guys to know that with a degree from the FCP program, this is the kind of thing that you can do. Also, it's great to see that you were able to come up with a project that you could do for the ambassadorship program that was remote from Antarctica that you had never even been to. So just a couple of observations that I wanted to make. I do have one question though. What age groups do you What age groups do you think were responding on the social media? Do you have any idea?
I'm sorry, what is what?
Age group, like
Oh,
how
age
old,
group.
how
Oh,
old
okay.
are the people? Were they
So
adults,
it depends on the social media. Instagram, I don't quote me because I don't know for sure, but I believe Instagram is more female based, and Facebook is both male and female, and I believe it's ages 18 to I think maybe 70 or 60-ish. I don't remember exactly.
You said you had 6 blogs.
8.
What? Oh, 8, sorry. What topics were they? And then do you know which ones people responded to the most?
Yeah, so all of them haven't been released yet.
Okay.
They're going to be released throughout the year. So I have blogs on recycling, no to plastic. I have blogs on ambassador reads, so for young ambassadors, what books they should read, sustainability tips, basically the ones with the environmental kind of theme.
Right.
See, Gina's listening in.
Yeah, Gina's here. Gina.
Hi, Gina.
Do you have plans to go down to Antarctica at some point?
They Gina, they hired me, so I'm officially full-time with them, which is really exciting.
Really? Wow, that's great.
When are you going?
No, the reason I ask is my son will be researching there.
Yeah.
It's fourth trip, but if he's going there down there in November,
Okay. Do you know what ship?
I'll put you in touch.
Which one?
I'll put you in touch.
Okay. Yeah, definitely.
Great. And Gina says Stella made an amazing impact this year with helping us engage more with our ambassadors and create new ones, especially with the younger audience.
Thank you, Gina.
So well done. So, well, no, don't want to do that. All right, so we've got Melanie Smith talking about storm surge. Next, she's going to be taking over the screen, which she did just now very effectively. And Take it away, Melanie. Shoot, do I have to change the speaker?
Can you hear me now?
Jackie? She's gonna hear. I went with it. Is it under, route?
Arrow next to mute. But it, yeah, the little arrow next to mute.
Yeah, okay. Melanie, can you hear? Can you speak?
Can you hear me?
Yes, oh, we're good, okay. Okay, take it away.
Hi, everyone. My name is Melanie, and I'm the Interactive Media Associate with the Storm Surge Working Group. And my project is titled Storm Surge Socials, using virtual platforms to convey the urgency of the climate crisis for urban and natural areas. So to briefly introduce the Storm Surge Working Group, we are a dedicated organization of leaders from different backgrounds, ranging from oceanography sciences to architecture, urban planning, engineering, policy, and advocacy. Each of our members is greatly concerned with the impact that climate crisis will have on New York and New Jersey, specifically extreme flooding due to storm surges, frequent storms, and sea level rise. So back to when the Storm Surge Working Group was founded after Superstorm Sandy. As you can see on the left side, the storm was very large and it had a large impact on coastal New York and New Jersey, including New York City. Transit systems were shut down, as well as schools, a blackout submerged Manhattan. Various homes and businesses were flooded and many were relocated, and 44 people were killed in New York alone. And though communities have been able to recover in the time since then, the conversation surrounding waterfront resiliency is still ongoing. The Storm Surge Working Group aims to be a leader in advocacy for protective infrastructure, specifically a seagate system, which is supported by accurate science and conversations across different mediums to different public constituents, policymakers, and we want to ensure that the damages faced during Superstorm Sandy cannot happen in the future as the climate crisis worsens. So looking at a history of communicating through science, a 2013 survey found that scientists mainly preferred sharing their findings through academic journals or through newspaper publishings, which the Storm Surge Working Group also did, with Professor Bowman submitting an op-ed in 2005, which was published in the Times, and also our Executive Council member, John D. Cameron of Cambridge Engineering, sharing in the Wall Street Journal why we're not prepared for another Sandy. But with the rise of the COVID-19 pandemic, social media use as a communicative tool for science also increased. But with there's also problems with communicating science through just in just the public areas. So unfortunately, a New York Times reporter misreported the price tag essentially of what we advocate for with the Seagate system. And former President Donald Trump had seen this article and further miscommunicated that information. And we did not have, the Storm Surge Working Group did not have a media team at the time. You know, it's very time consuming to kind of translate that over. So we were not able to directly respond to that miscommunication. Which brings me to my project, which is to create virtual platforms to the Storm Surge Working Group to actively and effectively communicate the science behind our advocacy, give some credibility to the organization, so put a face to the name. And my project I also wanted to provide insight into how these tools can be used to communicate other kinds of science as well. So starting with the first virtual platform I used was Instagram, and I created the account at MetroSurge to share different climate science content that I created using Canva, and I also shared other content from other accounts using our Instagram stories and posts. I also included different hashtags to broaden that audience and put it in front of the people who were interested. And I also wanted to establish virtual relationships to also increase audience engagement. So I would share posts from other organizations, and then in turn, they would also share my posts. So an example of a post I made, this is 2 examples, was defining the terms that support Storm Surge Working Group advocacy, like what is sea level rise, why flooding would increase, where it comes from, and then also what those consequences would mean for coastal communities and also natural areas. Another natural area I focused on was Jamaica Bay, where we were able to sail out and see the different wildlife that may be at risk, like the osprey we noticed, And also I created characters using the Little Miss trend that was popular over the summer and it's still popular right now. So I created the character, Mr. What is your evacuation zone, to encourage flood zone constituents to learn about their risk of where they live. And also Mr. submits a public comment on resiliency plans to encourage the public to give comment on resiliency plans, like the harbor and tributary study that will be released by the Army Corps of Engineers this September, I believe. And I also made those original op-eds and newspaper publishings more digestible for a fast-paced audience. Again, gave the face to the name, showing who Mr. Cameron is and why these op-eds are still relevant to our cause. And with our organization, we had 31 different environmental-based accounts follow our Instagram or interact with it in some capacity. So that includes different chapters of New York Sea Grant, Woods Hole Sea Grant, Virginia Sea Grant, the School of Marine Atmospheric Sciences, American Littoral Society, Waterfront Alliance followed us yesterday, and the Resilient Schools Consortium, which teaches students living in the flood zone about the risk related to climate change. And so just analyzing the Instagram, I made 55 posts over a 6-month period, which averaged 16 likes per post. But the most likes we had was 50, and that also garnered the most reach at 296 accounts. Our following grew from 103 followers to 216, and the most shared post was the trendy Little Miss theme that our audience was able to engage with. And then the second the second platform I used to create our website was Google Sites. And this is a screenshot from our homepage where we introduced ourselves, what our mission was, and that original op-ed that was posted in the Times. And our website features different resources for a general audience, including students, the press, elected officials, and general constituents. And on our website, you can find climate resiliency news articles, interactive flood maps, videos, technical reports, and other educational resources that, like I said, can be used to further understand the climate crisis and storm surge and sea level rise. And this website was used in a lesson plan for 6th to 8th grade students back in March. The school that I taught at was actually in the flood zone and experienced Superstorm Sandy. So we taught the students a little history lesson of what that was like and why that risk is still very present for them. And we also used the communicating science diagram to gauge where the students understood that lesson. And so this example showed that a student wanted to end global warming by speaking with engineers and protect his area from those sea level rise risks. And our usership increased over the course of this 7-month period. So we started with 33 users, and this July we had 68. So we averaged 57 users per month, and we had a peak of 80 in April. And even though the Storm Surge Working Group had been covered by the press in the past with those op-eds, or we were interviewed by Stony Brook University and CBS 2 News on our climate tour last year, having the website and the Instagram was able to have a home base that others could find us. And so the Discovery Channel reached out to us, and we're happy to share that we will be featured, or Chair Bowman will be featured in American Doomsday, which is a documentary that will be released in December 2022, focused on how storm surge and sea level rise will impact coastal cities like New York. And so some key takeaways from this project is that social media is a great way to engage with a dynamic audience in a way that is different from just in person or in newspapers, and make it more accessible to a wider community. Personal platforms also allow researchers to share their work and control that narrative or make corrections that may come out with miscommunications or misinformation, like that Donald Trump scenario. Virtual platforms can also give a face to the name and let people search you up afterwards if you have an article out, and they can learn more about your cause. And then also the most likely to be shared content is that the ones that follow a social media trend and kind of engage with all audiences or all ages. And so we'll be expanding into TikTok after this. And I'd just like to give a special thanks to distinguished Professor Bowman, who's in the audience right now, for his mentorship over the last 3 years and over the course of this project, as well as the other members of the Storm Surge Working Group for their guidance and support and trust in my creating their virtual brand. Also, all of our Metro Surge followers who shared, liked, and commented, and also friends and family who were watching, who have supported me in this project since the beginning. So thank you. And these are my citations.
Thanks a lot, Melanie. Do we have any questions? Liz.
Hello, my name is Isaac. For the past year, I worked for the New York City Ferry to save up money to come to grad school. And one of the most memorable experiences I have was I was working when Hurricane Ida hit. And even though it wasn't a particularly powerful hurricane, it dumped a lot of water on the city. And I actually ended up getting stranded at my work because all the subways got shut down and a lot of highways became semi-rivers. And so I ended up having to sleep on a boat until the next morning to find some transportation home. I was wondering if your website had any data on Hurricane Ida because I actually haven't looked at it yet.
Yeah, so we also share on our website our different newsletters, and it's called Surge Watch. I believe Chair Bowman wrote a letter about Hurricane Ida as well, because with the more intense storms, of course, rainfall will also increase. But we are mainly focused on storm surge flooding, which is also a concern because it doesn't need to rain for storm surge flooding to occur. Of course, like Hurricane Henry, there was extreme rainfall, and I think they happened within the same week or so. So it is definitely a concern, especially with combined sewer overflows that can be overwhelmed by rain. But yeah, we're mainly focused on storm surge and sea level rise flooding. But of course, rainfall is also a major concern.
Thanks. Anybody else?
So Isaac has asked an important question that connects to, at least for me, to the issue of differential impacts. Often impacts of storm surge and associated flooding are greater for lower socioeconomic groups, so-called frontline communities. And I'm wondering if you think that you need to communicate differently, depending on who you're trying to reach. You know, are you reaching the people who are reliant on public transportation, for example, with your social media posts? Do you need different social media posts depending on which groups you're trying to reach?
Oops, did we lose her? Ah. Hold on. I may have knocked her off. Shoot. Let's see. Melanie?
Yeah.
Can you hear?
Yeah, I'm here. Sorry.
Sorry, did you hear Paul's comment?
Yeah. Was it about the different posts for a different audience? Sorry, I was maybe muted. Yeah, I mean, I kind of, the content I chose was also based on like news at the time. So I defined sea level rise when the sea level rise technical report came out for NOAA. Definitely, as far as like the website went, we had an educational corner and technical report areas. So that's definitely a different audience for like 6th grade students versus researchers who may, want to do some more investigation on that end. So yeah, I mean, different content related for different audiences, but all on one or two platforms that was easily accessible for people. And also like the HAT study, the harbor tributary study will be coming out soon. So I was posting about that and what that might mean for people, but also the Little Miss trend, just to engage with friends who may
find it fun. I also made a post that was like summer tide tunes and posted a list of songs that were related to the ocean or tide in some way. So I did try to be engaging and fun with it, but also have that serious aspect as well.
Okay, thanks, Melanie. So we should move on, but I have to find the share screen button, which is now missing.
For shared screen,
Yeah,
you have to lift up the Zoom.
Yeah, you have to go onto the Zoom tab and just drag it up a little so you can see the bottom. No, just click on right here on the Zoom, like to get onto the
oh,
screen.
okay,
And then just drag it up so you could see the bottom. Yeah.
okay. So. Right. You can see it's been too long since I was teaching by Zoom. There we go.
So then you can just-
So you can,
Hi everyone, I am Lindsey Neuwirth, and this summer I completed a 10-week internship at the National Oceanic Atmospheric Administration, otherwise known as NOAA, at their Pacific Marine Environmental Lab located in Seattle, Washington. So I was remote for the first 9 weeks, and then my 10th week I had the opportunity to actually go to Seattle and work that last week in person. So my project is titled Communication Strategies to Improve Understanding of Ecosystem Dynamics. So first off, what is science communication? Science communication is how we share information, educate others, and raise awareness about scientific topics and research discoveries with a wide variety of audiences. So specifically at the Pacific Marine Environmental Lab, I worked with an organization called Ecosystems and Fisheries Oceanography Coordinated Investigations, otherwise known as ECOFOSI for short. So ECOFOSI was originally established in 1984 to study the recruitment of walleye pollock in the Shelikof Strait. And they were originally named just foci, but now they have expanded to study entire ecosystems in the North Pacific and Alaskan waters under their new current name, EcoFoci. So this expansion allowed for researchers to have access to the Bering Sea, which provides 40% of fish and shellfish in the United States, meaning that it is an extremely valuable commercial resource for livelihoods and also the economy. And this research collects baseline fisheries and oceanographic data to support the management of U.S. fisheries marine life in the rapidly changing U.S. Arctic. So as climate change is becoming of an increasing concern, it's really important that ecosystems are continually monitored with up-to-date data so that this can have an impact on fisheries management with data that they can base their decisions on. So why is this important? Well, first off, the foundational data that EcoFoci collects is vital to providing long-term and continuous data that supports the blue economy and a climate-ready nation. So especially given that EcoFoci's work takes place in the US Arctic, which is a location that is expected to experience pronounced climate change risks and has been deemed to warm over twice as fast as the rest of the globe. And EcoFoci also provides the context for the bigger picture. So the large scale data collection that they do provides resources for management organizations that actually need to rely on their science in order to be informed in the decisions that they make. And we also must generate understanding from policymakers and legislative affairs on the importance of supporting and continuing foundational research to ensure that there is enough money and sufficient funds being provided in order to not only continue their work, but also to further advance their work as technologies are improving. And then also in a federal setting, there is usually an expectation that there are scientific papers published based on the science, but as we all probably are familiar with, these are often a little bit lengthy and sometimes can be hard to understand. So the public and also policymakers might not take the time to actually go through and read them, or they might misinterpret the information. So managing that content and the why of the project that is being enforced in those papers are really important. So the objective of my project was to address the big question I'm asking of how do we effectively communicate foundational science to improve the understanding of ecosystem dynamics. So to start, there needs to be an established communications plan with identified key messages. This is going to provide a solid foundation for what messages need to be communicated and also kept consistent within all different communication strategies and materials that are going to be made. So within NOAA specifically, this is then further supported by a range of different materials to convey those messages. So we have social media campaigns, web stories, visual platforms such as ArcGIS story maps, fact sheets, and postcards from the field, which I will get into a little bit more. And then through these objectives, I aim to share knowledge so people can easily comprehend the importance of foundational oceanographic research. So the approach to effectively communicating foundational science starts with setting goals and planning ahead. It's also so important to be knowledgeable about the entirety of the program. So in my case, ecofoci, you really need to know the big picture in order to understand the importance of each individual smaller project that is supporting the program's overall goal. And then everything needs to be in plain language, so avoiding jargon and spelling out all acronyms, which in NOAA there are a million different acronyms that not even people that work for them can keep up with. So spelling those out is really important. And then it's also important to stay unbiased and present the facts, which working for a federal agency is very different than working with non-governmental agencies. They have a little bit more freedom to be more persuasive and add a little bit more of a personal voice in there, whereas federal agencies need to abide by what the current administration is supporting. And then also you have to ensure that content is accessible for all. So all images and graphics must have an alternative text, which is basically just a short little description of what is going on in the visual. So first we have, this was my big project that I worked on this summer, was an ArcGIS story map. So story maps basically combine text and visuals such as images, maps, and interactive media to tell a story. So the purpose of my story was to communicate exactly what ecofoci's data collection does and highlight what that data collects, what that data tells us, and then ultimately tie it back to the bigger picture of supporting a climate-ready nation and also concluding with the implications of a changing environment. So my story map is currently going through different NOAA required review steps before it can actually be published. So hopefully that will be up soon. And then we have web stories. So if you want to read this full story that I wrote, you could just scan that QR code. But basically this was just a web story I wrote about a research flight deployment about Arctic ocean heat fluxes. So these are often just great ways to write a short story that can be published on the lab's website to keep everyone up to date with what the lab is doing. And then we also have social media campaigns. So the campaign I worked on was to support a 4-series blog post that was already published, and it was about a spring research survey that happened before I got there. So the social media posts served to direct more traffic to those blog posts and also summarize what was going on. So actually that middle post on the middle screen was the top post by reach on the NOAA Fisheries Alaska Facebook page, which was kind of cool. And then here are just some other things. So the communications plan, which I talked a little bit about before, but that will have the key messages, the materials that are going to be created, the people that are involved, and then also potential questions people might have. So to make sure everyone is on the same page with everything that the program is trying to convey and the messages that they're supporting. And then we also have postcards from the field. So that is an internal NOAA means of communication. So basically different projects can support postcards from the field, and then NOAA Communications will send them out to everyone within the organization. So that's just the most recent one that they send out. It's just some pictures and then a short description underneath. And then lastly, we have fact sheets, which is a great summary of all of the different research and key messages that the organization does. So I help to update and reformat this so that way when the lab director goes to Washington, D.C. and visits Capitol Hill, she can bring this with her to show policymakers and members from legislative affairs. So some key takeaways that I had is how to direct a researcher to the answer. So what I mean by this is not necessarily like asking them to tell me the answer that I want to hear, but directing them to tell me the information that is going to support the bigger picture. So oftentimes a lot of scientists, when you talk to them, they're going to share different ideas that they're really enthusiastic about and different things that happened internally that supported their research, but those are often hard for people to understand why that matters. So really taking that enthusiasm and directing them to tell you how that fits into the bigger picture is really important with science communication. And then also time management. So making sure that stories are done in time so they can be promptly posted when our research cruise is going out or just coming back, and then also preparing ahead of time. So for example, EcoFoci does a spring and a fall research cruise every year. So you know you'll need those stories. So prepping them ahead of time and then filling in the blanks later when the time comes is also very time effective. I learned that key messages are really so important. Having consistent key messages and repeating them in all forms of communication are how you're really going to get your audience to retain that information and know exactly what your organization is doing and why it's important. And then also data-driven decision-making. So using methods such as search engine optimization and data analysis to drive what images are the best, what captions are the best, what keywords, what hashtags, and all that stuff. So the broader significance and impact of having effective communication strategies is that it will ultimately allow for the EcoFoci program to have sufficient funding and support. And having enough money and support is going to allow for their data collection to continue and advance further to provide more science for fisheries management. It's also going to allow for them to continue to monitor a rapidly changing ecosystem so that we can know what's going on as climate change progresses. And then also sufficient funding will allow them to continue their modeling efforts with the data that they collect so we can make predictions for the future. And then EcoFoci also sets an example for all foundational oceanographic research. So within NOAA and just worldwide, there are so many different organizations that provide foundational research. So they can provide a good example for science communication and also vice versa, getting tips from other organizations. And then it also supports NOAA's mission of understanding and predicting changes in climate, weather, ocean, and coast to share knowledge and information. These are my references.
Thanks so much, Lindsey. Questions?
Thank you, Lindsey. That picture answers one of my questions. Did you actually get to the Pacific
Yes.
Marine?
So
So
that's
was
me.
most of your work on the West Coast or was it remote?
Yeah, so I did the first 9 weeks remote online, and then my last week I spent.
Okay, 1 week.
Yeah.
Great. Yeah, so you talked in very general terms about communication. I'm wondering if you could give us an example of a term that I use frequently and how you explain this one to a general audience, and that you talk about ecosystem dynamics or ecosystem-based fishery management. I think that is, it's a hard term. So maybe you could give us an example about how you got that message across.
Right, so a good example that is relevant to ecofoci is that with warming waters, fish are moving further up north. And the further north they go, the closer they get to leaving US waters. So it's important that the different changes in the environment are communicated, such as the warming temperatures and seeing where the fish are going in order to kind of get ahead of that and prepare for a time when those fish might not be in US waters. So working with other countries to create treaties and whatnot to protect like sustainable resources, but then also being able to still maybe have access to those resources in the future. Does that kind of answer your question?
That's a good example. Thank you.
Any other questions? All right, thanks again, Lindsey. Okay, so next we have Paul.
Probably have to stop sharing and then reshare. Can you just share your screen versus sharing PDF or that's sort of better?
Great, thanks, Paul.
This working? Great. Back in my high school theater days. You don't want to hear me sing Poor Judd's Dead before I do this? All right. Just Mike? Okay.
No, I want to hear it.
After. That can be one of the questions. So for those of you that don't know me, my name is Paul Mooney. For those of you who do, I'm sorry. I'm going to be talking about sharing everyday environmentalism, which many of my colleagues have already done some great presentations about science communication, which is good, so I don't have to explain it that much because I left that slide out. I'm going to be talking specifically about the use of narrative in communicating science and conservation science. I'm going to be using the word science, but I consider that an umbrella term that includes conservation. So just an overview of what I'm going to be talking about, brief introduction, going over narrative in science communication, talking about some of the ethical considerations some people have about narrative in science communication, going on a little rant about that, coming off my soapbox to talk about my particular project this summer and the feedback I got from a wider audience and more importantly, my subjects, and then takeaways and conclusions. So hopefully none of you in this room are thinking, what does narrative have to do with science communication? And that it might just be somewhat a recent thing that happened as more documentaries get made. But I'm going to read a passage and then talk about it and hopefully change the minds if there are any that need to be changed. The neighborhood of Puerto Praya, viewed from the sea, wears a desolate aspect. The volcanic fire of past ages and the scorching heat of a tropical sun have in most places rendered the soil sterile and unfit for vegetation. The country rises in successive steps of tableland, interspersed with some truncate conical hills, and the horizon is bounded by an irregular chain of more lofty mountains. The scene is beheld through the hazy atmosphere of this climate as one of great interest, if indeed a person fresh from the sea and who has just walked for the first time in a grove of coconut trees can be thinking of anything but his own happiness. Now that, to me, reads like the opening of a book by Robert Louis Stevenson, or Jack London, or H. Rider Haggard, for any y'all Alan Quartermain fans out there. It was actually written by a young naturalist and biologist. It was part of a series of nonfiction books based on journals of government surveying expeditions. Does anybody recognize this guy? Just out of curiosity. Well, it's a picture of him when he's pretty young. And the book that came out, this nonfiction book, made him pretty famous. It was a very, very successful nonfiction adventure story that also included a lot of his scientific observations and thoughts, and formed part of the basis of a book he published 20 years later on the origin of species. At which time Charles Darwin was already famous for writing volume 3 of the adventures of the travels of the adventurer and the beetle. So telling stories and communicating science through a narrative has been an important tool of scientists since for centuries, essentially. And I think many of us in this room, if we really think about it, probably first were inspired to go into science or just to want to learn about science by people who use narrative to communicate it. Some of the greats in our own lifetimes, people like Jane Goodall, David Attenborough, Jacques Cousteau, whose star has fallen recently, which bums me out. If you don't know what I'm talking about, don't look it up. It'll ruin your childhood. Like it ruined the Crocodile Hunter, and of course, the two great Carls of narrative science communication, Sagan and Savina. I had to do it, Carl. I'm sorry.
I would have wanted
I was hoping you were going to be here so I could call you out a little bit on that. But anyways, so yeah, narrative is important in communicating science. Now, narrative and science communication, what I really mean when I talk about that is stories. I use sort of storytelling and narrative kind of interchangeably, even though there are differences if you want to get down to the Webster's definition. But narrative is how humans have communicated the abstract for thousands of years through stories. It's how our ancestors told their friends where the mammoths were and how to hunt them. Again, this great quote, the primary means by which human beings order their social reality is through narrative. And repeated studies have shown that when information is put into a narrative, a story-like form, people comprehend it better, they remember it better, and it is more likely to convince them, persuade them to either change their mind or take action. It creates an emotional connection. It makes people care, and by caring, they process it better. Now, I've read a lot of papers about narrative communication, and a lot of them talk about the ethics of it, and a lot of them question the ethics of it. They bring up the idea that because it is so inherently persuasive and reaches to an emotional core instead of coldly conveying facts, it in and of itself is unethical. That comprehension entails persuasion, and persuasion leads to propaganda. Going back over 20 years to one of the first big studies, a lot of the other studies I read quoted in the sort of post-internet age about whether or not narrative is ethical, refers to it as the power of it is something to be feared. And then 20 years later, another paper talks about it as a cause for concern. And that's kind of nuts to me, because my opinion is, come on, who throws out a tool because it's too useful? Now, I, for one, and like a third of the people in this room are sick of hearing me reiterate this, I do not come from a professional academic science background. I'm a writer and filmmaker. That's what I do. So I'm a narrative guy. I came into this as a narrative guy. So it's no surprise, I think, that this is how I feel about it. But, I just think all the ethical hand-wringing that happens is absurd and kind of, the idea that narrative should not be used in science communication, to me, it's throwing the baby out with the bathwater, because the idea that because something is just too good to be employed for good causes is nuts to me. I mean, say something persuades someone, finally, that COVID-19 is real, that global warming is real, that vaccines aren't a plot by the lizard people to turn us all into communists. Like, yes, that's persuasion, but how could that possibly be unethical? As long as the story is told with the facts and nothing is changed or lied about or obscured, then why not tell stories to explain our science? And that's my thoughts on it. So again, soapbox off, time to talk about my project. So I had the good fortune this summer of interning at the Link, which is the new and still somewhat developing publication of the Elllen Center for Communicating Science right here at Stony. So I had a lot of normal interning tasks. I also wrote a lot of articles and edited a lot of stuff for them, but they also allowed me to write a series of articles that I gave the overall title, Everyday Environmentalism. And what I did is I followed 4 of my fantastic colleagues here in the MCP program as they went about their particular scientific work this summer and wrote articles about them, but articles written as sort of the structure somewhat of more of a nonfiction short story than just a straight up report on what they were doing. I wanted to inject people and an emotional connection with the reader into these stories about science. So first one I did was the orgies of underappreciated arthropods about horseshoe crabs. You can guess who that was. Article 2, surveying for sustainability in the sea. I really like alliteration. I'm so sorry. I find that great. About recreational fishery surveys conducted by the DEC. Fluxia filters, oodles of oysters, and a caring community about shellfish restoration project at the Cornell Cooperative's aquaculture facility in Huntington. And enriching lives by gathering garbage about the environmental and societal value of beach cleanups. So audience feedback that I was able to get through website analytics was unfortunately somewhat limited. Again, the site is still up and coming. It's still developing. They're going through their sort of growing pain issues. And due to technical issues, only the first 3 articles went up in time for me to get analytics data back. But what I did see when I went through it and looked at the numbers was that my articles with these, narrative tones did have higher averages of unique viewers a day and longer time spent on page. That was universal. Over time, average unique viewer per day dropped off. It basically showed that after the first week, not as many people read it. So the averages for articles that were up longer were lower, but compared to ones that went up around the same time, the everyday environmentalism ones were higher. So again, I had a small data set. It was over a relatively short period of time. So obviously this is not, any kind of big finding that'll turn any heads, but it does match with the idea that narrative grips people more and provokes a stronger interest. So this is just, the numbers. What was definitely more interesting, I was more excited about to me, was the feedback from my subjects. I had all 4 of them. They were kind enough to fill out a 16-question short answer survey, 14 real questions and 2 joke ones, because, overall response was very positive. All 4 of them liked the way I depicted not just them as people, but they liked the way I depicted their work, talked about the topics that they cared about, that they were working on. It was positive. They seemed to actually enjoy it. They were there was excitement. One of them even said it finally helped him explain what he does at work to his mom, which is just I wasn't going to name you, but you're over here grinning and blushing. One found a minor inaccuracy in my article, so my bad. That was my mistake. I mischaracterized the level of one anthropogenic threat compared to other ones. So, not like a huge error. They're all big problems, but I messed up. Sorry. And 2 of them expressly wished that there had been more sort of technical details, statistics. One felt I left out one of the aspects of their work. And again, that was more intentional because I didn't want these to have a lot of, numbers and statistics. And again, it's sort of just for brevity's sake, I couldn't include everything because my colleagues, all of them, are, the particular ones I worked with, had so much that they're doing and so much that they're interested in. I can only talk about so much in an 800 to 1,000 word post. But even with those sort of dings, again, the feedback was very positive, and all of them said that they support and enjoy the use of narrative in science communication. But they had also already had that opinion anyway, so I didn't change any minds. But still nice to hear, because it's good to know that sort of people who are interested in science also understand that narrative is important. So the big takeaways are, yes, my hard data was limited, but what little I was able to see does agree with the idea that narrative is just more effective. What I hope is a growing consensus that narrative in science communications is both ethical and vital. It's reflected by my subjects, and I hope that's indicative of the entire crop of next generation of scientists. But due to that feedback, I sort of reconsidered the idea that not reconsidered, but it made me understand that narrative needs to be a supplement. The need for pieces with that hard data, with those numbers, with the graphs and charts and the things I skip over and all the science articles I had to read for this course is important. Narrative needs to be a supplement. There still needs to be that well, written and edited academic writing. So narrative is a supplement. It's a gateway to get your message out to a bigger public. And that's too crap to do it. Any questions?
Nice to meet you in person, Paul.
Yes,
I
nice to meet you in
remember
person.
it was hard to get you into the program, remember?
Yeah, I wasn't
Because of the Veterans benefits and all that stuff, but I'm glad that we got you in.
Loved it.
Yeah.
Thanks
so-
for convincing me.
Yeah, sure. What are you gonna do next?
See who hires me.
Any leads?
Still waiting to hear back. But I mean, this is what I want to do. I want to write and do content creation because my background again is writing and film, and I want to do that on behalf of science and science conservation. So I'm waiting to hear back from basically pretty much anywhere that does conservation or marine science on the East Coast. And if they have a communications position open, I've applied. So I'm waiting to
So
hear
you have
back.
a lot of applications.
Oh yeah.
Great. Okay, good luck.
Thank you.
Did you mention your definitions of narrative and of story in your talk just now?
I did not. To me, narrative is more of a specific framework, setting up, that has characters you can identify a specific place where, the action actually happens, and there's sort of a course of events, whereas storytelling to me, I just think of it as a more sort of nebulous term, as sort of being able to take whatever information you want to convey and sort of put it into a story. I know it's kind of vague, but I could look up more specific terms, but that's just sort of in my head when I think about it.
Is there like an age at which in the literature, at least, is there an age at which like telling narrative becomes unethical? Because I was wondering, like you tell kids stories about like scientists, but like when?
I mean, I don't think it ever stops being okay to tell stories and
No, I
read.
just meant like in terms of what you're trying to convey, like that it was kind of perceived that way. Like, did they say like, once you're an adult, like you have to understand the science in a sciencey way?
I didn't actually read anything that made any distinction. I think it's because most of the articles were sort of written with, the understanding that people reading them were people interested in science communication. So it really didn't draw any sort of boundary there. But yeah, it'd be interesting to learn if there were people who did have like a specific sort of take on that.
Great. All right, thanks, Paul.
Thank you. Oh, I didn't say, sorry.
Okay, so next we have Sarah McDonald, another one of our NOAA internship fellows, I guess.
Oh, you say that, yeah.
Fellows. It's gender neutral term.
You're like a 90s pop star.
Is that effective? Everyone hear me?
Yes.
Hi, my name is Sarah McDonald. My presentation is titled Communicating Science in the Gulf of Mexico. This is a culmination of research that I did with the NOAA Restore Science Program. My internship was fully remote. I did not go to Seattle or anything. I wish I did. So I know the title of my presentation is pretty generic, so I'm going to give you a brief outline before I really get into it. Our office was started as a result of the Deepwater Horizon oil spill, so I'm going to go into a little bit of background about that disaster. Then I'll talk about my office, the legislative mandate that funds my office, our approach to our restoration efforts, how we take advantage of how we use co-production and part of our restoration efforts, examples of a funded project that we that just recently completed, as well as the future of co-production within NOAA, as well as my thoughts on the future of co-production, and then I will take questions from you guys following that. Okay, so the Deepwater Horizon oil spill is named as such because that is the name of the oil rig itself, which is that lovely little eyesore in the top photo. You may also hear it known as the BP oil spill or the Macondo blowout. It is known as the BP oil spill because that is the name of the company who had the rights to explore the area that the rig was in. The Macondo blowout is named so because that is the name of the prospect that they were drilling in. So you may see all three of these names across the research. It's all the same, but there's some confusion along those lines. So this disaster occurred on April 20th, 2010. It occurred when a methane gas pulse came up through the well and ignited. It resulted in the death of 11 workers as well as 17 pretty bad injuries. The rig was on fire for 2.5 days. The flames were inextinguishable
It only went out when the rig sank about 2.5 days later. And the wellhead sank about half a mile away, or sorry, the rig sank from about a mile and a half away from the wellhead. There were 3 different sources of oil: the rig itself, which sank, the wellhead, of course, which is the main one, but then the riser as well, which is the 1,400-foot tube that connects the rig to the wellhead, was filled with oil when it sank. So there was just oil on all fronts, and the wellhead was not completely sealed until September. So it was about 5 months of constant oil spills. They siphoned a little bit of it, but it wasn't completely sealed until September. So what did they do? Well, they tried their best to contain it with skimmer boats, which basically act as vacuums. That's that photo up top, to try and get some of the oil off the surface. They also did controlled oil burning, which came with its own set of issues. Dispersants to try and break down the oil so that the ocean microbes would consume it. That didn't really work. They tried it from planes. They tried it to insert it directly into the wellhead, but there was 68,000 gallons of oil being released per day. So the dispersants didn't really have much effect. They did a freshwater release from the Mississippi River later on, which was a little better, but again, 68,000 gallons of oil a day just cannot really be handled. They were wholly unprepared for the spill. Restoration efforts were just sifting the oil from the beaches because it clumps as it goes onto the beach, and so they tried to just take it out manually. Cleaning the marine animals, you've all seen the Dawn commercials, and planting new marsh grasses following the erosion. However, they tried their best, but they were just, again, wholly unprepared. In total, there were 134 million gallons of oil released, which led to a myriad of environmental disasters. But a few of the numbers are an estimated 1 million seabird deaths, 8.3 billion oyster deaths, 10 plus square miles of seagrass were impacted, and thousands of marine mammals and turtle deaths. So we turn to policy. 2 years later, the Resources and Ecosystems Sustainability, Tourist Opportunities, and Revived Economies of the Gulf Coast States Act, or if you don't feel like saying all of that, the Restore Act was enacted in 2012. It was a means for long-term research efforts that provide better understanding of ecosystem science to inform restoration efforts and assess recovery. This is the mandate that led to my office being founded. So this is just a little brief breakdown of where the BP money went. So they paid quite a lot in civil penalties, criminal penalties, and natural resource damages. Transocean is the Swiss contractor who commissioned the construction of the rig. They paid $1 billion. And Adargo was the petroleum company that had about a 25% stake in the well. And then BP, of course, paid most of it. That which led to the Restore Act, which led to all of these things. And then right here is where my office is. We got about 2.5% of the civil penalties and 25% of the interest, which is how we keep our office going until now. The mission of my office was to carry out research, observation, and monitoring to support the long-term sustainability of the ecosystem, fish stocks, fish habitat, and the recreational, commercial, and charter fishing industry in the Gulf of Mexico. This is for the sake of understanding the Gulf of Mexico ecosystem in an integrated, holistic manner, so that management of and restoration activities within the Gulf of Mexico ecosystem is guided by this ecosystem understanding. So it's for the sake of management more than anything. How do we do this? We have annual funding competitions. Where so far institutions of higher education, nonprofit institutions, federal, territorial, state, local, and tribal governments, and for-profit organizations have submitted letters of intent and then grant proposals, and we will give out funds based on what is most needed in management at the time. Anyone can apply as long as your research is in the Gulf of Mexico or on a process, habitat, or species with a direct, significant, and quantifiable impact on the Gulf of Mexico. A lot of our funding competitions are driven by this idea of co-production. So again, we look at what's needed. We look at what resource managers are asking for. And then the resource managers such as fishery managers, wetland restoration managers, land use planners, and then most of our projects also have review panels that include resource managers and researchers. So from top to bottom, several people are involved. It's not just scientists. It can't be just scientists. This idea of co-production, so there are lots of definitions of co-production. I've read some research papers based on this idea, but this is our office's definition, which is the collaboration of researchers, resource managers, and other stakeholders, including resource users, across 4 phases of a research project to inform a specific natural resource management decision. So the 4 phases are scoping, which is the identification of a specific natural resource management decision to be made in the future. So this is just establishing communication, collaboration. Design, which is getting your team together to develop your approach for acquiring that information that you're looking for. Developing research questions, methods, reducing all those uncertainties. These 2 things need to be done before you submit grant proposals to the NOAA Restore Office. Then following that is the research. So environmental observations, conducting surveys, research papers, all that stuff is step 3. And then transferring the information. This is actually putting what you've researched into use. So training resource managers, using findings in the decision-making process, all that stuff. But the main point of this is necessarily everyone is involved from top to bottom. It's not just scientists in one part and then someone takes over a second part. Like it's scientists, managers, partners, all together throughout the whole thing. We funded so many projects that use co-production, but this is one specific one that did it amazingly. It's titled The Gulf-Wide Assessment of Habitat-Specific Production Estimates of Nekton in Turtlegrass. This project is massive. We funded it in 2017 and it just finished in 2022. They saw this project through hurricanes, the pandemic. I believe their lab caught fire at some point. Someone broke their arm on one of the research trips. I mean, everything that could, this is a direct quote from one of the researchers, he said everything that could have gone wrong went wrong. But it but they pushed through just because their co-production was just so strong. And they were looking at what happens to seagrass and the marine life that rely on it when the environment changes and how those relationships differ across the Gulf of Mexico. So there were 6 sites and it was all the research was being done simultaneously across all 6 sites. This project was massive. No one had done anything like it before. Their goal was to conduct a management-driven Gulf-wide assessment of the use of turtlegrass as habitat by Nekton and to evaluate the support provided specifically to the economically valuable bluegrass. So it's just a fancy way of saying looking at ecological relationships. So there was no one direct product from this. There was several things that they looked at. They even looked at the hurricane impacts just to inform fishery management. And the results of this project led to several more projects. It's super interesting, but it would take half an hour to go over, all the things that they really learned. So if you want to learn more about it, there is an article on our website, which was written and published by yours truly. It's on our website, and I had the pleasure of speaking with 3 of the investigators on this, and they said they had great success in terms of the reach that they've had for this project. They've been fortunate enough to work collaboratively with expert advisory panel members, and they really want to foster those collaborations moving forward. So this was just a basis which will lead it to several more management decisions and research and all of that stuff. Amazing project, amazing work. So the future of co-production, this is just from the NOAA side. We are conducting workshops, webinar series, conference sessions, also that different institutions can start integrating co-production into their restoration projects and research and all of that stuff. We currently have a funding opportunity going on, which is titled Executing Actionable Science. We have about $15 million to give out to around 10 projects. But project teams must include a resource manager and directly inform a management decision in the goal. This opened in June 2022, and I am currently in the process of helping my office review letters of intent as well as grant proposals. So we'll see where that goes. But as far as my own opinion in co-production, I would like to see it applied to even greater. I mean, the BP oil spill was a huge disaster, but how do we tackle stuff like climate change, marine protected areas, even aquaculture? Like I just, at this point, I've learned that scientists communicating with just other scientists is basically an echo chamber. And even Paul said, communicating with storytellers, getting companies who are contributing to climate change in a room with scientists who know how to reduce carbon emissions. That's our best shot. Getting federal agencies in a room with indigenous people from Alaska and Hawaii to actually establish marine protected areas with people who know the land versus people who are trying to protect it. I think that's our best shot. It has to be everyone. It can't just be scientists communicating with scientists. We have to collaborate. Again, I've read several papers regarding co-production, but I've read one that I really liked. And they gave like a model or a how-to guide basically. And they gave several steps, but this is kind of one of the main ones. So they speak to managers and they say, approach scientists with a management need, goal or problem rather than a request for a product. So give, your need instead of what you want the end goal to be. Scientists, before suggesting specific products, make sure you understand the decision to be made and the environment in which the decision will be made. And partners, invest in at least one in-person meeting of all potential partners and stakeholders to specify the types of decisions to be made and the types of scientific information needed to support these decisions. That's the authors in the paper in case you want to read it. It sounds cliche, but nonprofits, corporations, brands, scientists, federal agencies, we all have to collaborate. We just have to. That's our best shot of really pushing towards a sustainable future. We can't do it, by ourselves. We need everybody. Questions?
Thanks, Sarah. Any questions? Or too quick? Time?
So you mentioned this thing that's open now for $15 million for 10 projects. Is that, well, first, is that the entirety of the funding that comes out of this restore program on an annual basis?
No, so it depends on what management is needed. So how much money we give out per year is not really up to us as much as the higher ups. So our office is a subsection of NOAA. And so we just kind of go through the letters of intent and the grant proposals, and they tell us what management is needed, and we just kind of check off some boxes. And so no, each year is different depending on what management is needed and how much money we think needs to go towards specific decisions. So I think we've been doing competitions for about 5 years now, and it's usually in the range of 15 to 10 million per year, but it's not exactly the same every single year.
And what's the closing date for this particular opportunity?
I think the letters of intent were due this week. And so now we're going to send them. So that's just for feedback. Anyone can still propose, can submit a grant proposal, but without our feedback from your letters of intent, it's not as likely that you'll get funding. But you can still submit a grant proposal if you wanted to. I actually think when I was looking through our applicants, there was a Stony Brook one in 2019, I believe. I don't know if it got funded, but I know that someone here applied through this office. So. Yeah.
Is this organization currently hiring, or does it have internships available? It sounds like a really cool place.
I wish they would hire me. I don't believe so, but I'm their first intern that they've ever had. So, and I found out about it through the school. So keep an eye on your email account because that was how I found out about it. So, but yeah, if you want to follow the newsletter as well, I think we don't have a social media account because we're such a small office, but we do have a newsletter. So I think if any opportunities come up, it will be in there. But definitely, best advice I can offer you through this program is to keep an eye on your emails because they will send you opportunities like this. And that's how I found this one.
Okay, so our next talk is Johanna Grennan, who is presenting remotely, but she is the third of our 3 NOAA interns this year, which is a wonderful opportunity for all you incoming MCP students. It comes with a Dean Scholarship that helps participation. And this year, many of the fellowships could either be remote or in person. I think moving forward, more of them will be in person, but the flexibility of this program and the number of potential placements is huge. And what a great opportunity to work with, our lead federal agency in protecting the oceans. Pretty cool. All right, Joanna, are you there?
I am. Can you guys see my presentation?
Yes, we can.
Okay, is it big? I can't see.
It's big.
Okay, great. Hi guys, my name is Joanna, and today I will be presenting taking a deeper dive into NOAA communications. This summer, I began my internship with NOAA's Office of Oceanic and Atmospheric Research, OAR. This office oversees NOAA research labs and offices, including National Sea Grant, Ocean Exploration and Research, the Climate and Weather Programs offices, Ocean Acidification Program, Uncrewed Systems, and the Global Ocean Monitoring and Observing Program. In 2020, the OAR strategy was released outlining the future for OAR. Focusing on the next 6 years, strategies, goals, and objectives were identified throughout the organization to better serve the needs of the American people through science, a focused mission, collaborative partnerships, and achieving results. This includes the need for communicating science about the importance of oceans, coasts, and the Great Lakes. Other initiatives include strengthening collaborations between internal and external groups. My supervisor, Murph, the director of communications, had a bunch of different ideas for me to help NOAA communicate their research and sciences to different audiences. Today, I'm going to focus on 2 departments that I worked closely with, the Ocean Acidification Program and National Sea Grant. So the National Sea Grant Office does a ton of different things, including providing funding to Sea Grant colleges and oversees funding competitions. I joined weekly team meetings and met with their staff regularly to discuss the inner goings of Sea Grant programs, including the recent release of Guam Sea Grant achieving institutional status this summer. Whoops, sorry. Hold on. Whoa, my whole screen just went kaput. Technology, guys. All right. The National Sea Grant has an abundance of programs that they fund amongst their 34 offices across the United States. Part of the National Sea Grant work is for healthy coastal ecosystems, which includes funded projects in ocean acidification, oyster restoration, and coastal tourism. At the end of June, the Biden administration released the Infrastructure Investment and Jobs Act, which allocated about $3 billion of funding to NOAA over the next 5 years. Part of this money will go to the $19 million in federal funding that Sea Grant announced to address the removal and prevention of marine debris. To help create interest in these funding opportunities, I created a web page for marine debris prevention and removal, and those interested in applying for federal money will be sent through this page. This web page uses pictures, text, and alternative text, which, like you heard from Lindsey, is a text description of the images to communicate marine debris issues and mitigation projects. So like Lindsey was highlighting earlier, those sea maps are projects that we're all highlighting. So these are currently in progress and released to the public. And images that I chose for this web page were picked for a purpose. In an attempt to show more representation in science, all photos of people published on the page were of diverse groups. So that was a conscientious decision on my end. I'm so sorry. God, guys, I should know Zoom by now. The Ocean Acidification Program coordinates research, monitoring, and other activities to improve our understanding of the chemistry of how oceans are changing, how fast they're changing, how it varies by the region, and the impacts that ocean acidification has on marine life, people, and on local, regional, and national economies. Currently, they're conducting a NOAA East Coast Acidification Cruise, ECOA3, which measures CO2 and seawater to better understand ocean carbonate chemistry and biological productivity in the ocean. In 2014, NOAA and OAP released an education implementation plan to engage audiences and teach them about the impacts of ocean acidification due to anthropogenically released CO2. This includes creating locally and regional focused education and outreach programs. Regional education toolkits were created for teachers and educators to teach their students about ocean acidification in classrooms across the United States. So as part of this plan, I updated and created new content for 2 educational toolkits. Both toolkits teach middle school students about ocean acidification, its effects on the ocean, and ways we can work as a community to help mitigate some of these issues. So it uses framework values and educational standards. It includes a background, an alternative script, activities, and student worksheets. The toolkits are still under review, so I'm going to share images from slide decks that I created to accompany the toolkits. The first toolkit, Hey, What's All That Commotion in Our Ocean, was created for Pacific Northwest educators to use in conjunction with the activities as ready-to-go presentations for their students. The second toolkit, Connecting Land, Air, and Sea, Ocean Acidification in Hawaii, was created for students in Hawaii to learn about ocean acidification. This is an example of a general background slide that I created from the slide decks. Both slide decks include this background in ocean acidification and ways we're increasing CO2 emissions, which drives ocean acidification. Then they go into each module within the toolkit. They introduce keywords and definitions from within the modules. And then they have a material list with a picture of materials for educators and students that might benefit from a visual. It includes worksheets that were created to incorporate supporting questions to give both students an area to jot down ideas and commit information to memory, but also gives the teacher time to settle things down after an activity. It then finally has discussion points for each activity. And for the Hawaii toolkit, a main component was to tie it to Hawaiian culture and their strong ties to the land and sea. So by using Hawaiian native language, keywords were identified and defined with pronunciation to be included within the modules. The toolkits will be released to Hawaii and Oregon and Washington schools where they were tested, and then more broadly. They'll also be available on the NOAA OAP website and in OA education collections throughout other parts of NOAA. But to find out how students and educators were going to use these toolkits, I created two surveys, a student and an educator survey. The student survey asked middle school students when they began learning about science, their comfortability with the ocean, different learning methods that they use in science class, calculating interest in marine education, and to see if they can identify or recognize concepts related to ocean acidification. The survey included visuals to accompany the text to help students who may struggle with reading comprehension or benefit from visual aids to ensure that the survey was all inclusive. So for results of this survey, the majority of students surveyed started learning science in the first or second grades, but at least a third of those didn't have a science class until the third or fourth grades, which is very typical of Boston Public Schools. All students had taken a science class, and in their classes, they used different learning materials, including lectures, individual and group experiments, and read from textbooks or completed workbooks. Almost 90% of students surveyed had an interest in learning about marine life in school, and 90% of students also liked fish, whales, or coral. 99% of students surveyed had heard the term climate change, 95% had heard the term global warming, but only 62% of students had heard the term ocean acidification. Almost 90% of students surveyed would want to do a hands-on experiment to learn about the ocean in science class, and more than half would benefit from watching a slideshow or PowerPoint, and even more would be interested in watching a documentary or movie to learn about the ocean. The educator survey went out to 12,000 educators across our 50 states and territories, proposing questions on how educators teach, their grade levels, where they teach, and distance from teaching location to oceans or Great Lakes. The second portion of the survey asked educators on their familiarity with some concepts that the toolkits encompass, as well as concepts that are widely discussed within the scientific community: climate change, sea level rise, and ocean acidification. Finally, questions were proposed asking educators what kind of education materials they would like to see in a toolkit, ways their students can learn efficiently, their familiarity in education materials available from NOAA, interest in using this material in their curricula, and if they weren't interested, why. Educators surveyed were a mix of traditional classroom-based educators and informal non-traditional classroom-based educators, and came from 41 different states and territories, including Puerto Rico, American Samoa, and the Commonwealth of the Northern Mariana Islands. And there were also other countries represented, including Austria, Australia, Canada, and Hong Kong. 90% of educators felt familiar with climate change and sea level rise, but only 70% were comfortable in understanding ocean acidification. When educators were asked if their students had a general knowledge of climate change, more than half said yes. But again, when educators were asked if their students had a general knowledge of ocean acidification, an overwhelmingly 86% said no. When asked if educators were familiar with educational toolkits from NOAA, it was pretty split. Over half of the educators surveyed had at least 30 minutes to an hour with their students, which is enough time to complete a module. And more than half of those surveyed felt like they would benefit from toolkits that had both hands-on and interactive demonstrations of scientific phenomena, and the other half thought presentations with slides would be helpful. Overwhelmingly, 3/4 of educators surveyed would be interested in using ocean or coastal science NGSS aligned lesson plans with supporting resources, even if there was a need for out-of-pocket expenses for materials used in the toolkits, and would incorporate them into their curriculum. Of those that said no, the biggest reason would be a lack of resources, including funding. As a former educator, I know firsthand how much public school educators put into materials for their classroom and students during a school year. Other responses included not having enough time or having it not fit into their curriculum. So some takeaways from the surveys. Students want to learn about the ocean and the life within it. Some have had prior exposure to learning about the ocean and others haven't. If they have learned about the ocean, some mistake properties of water or learning about the water cycle to mean that they've learned about the ocean. This is a very baseline survey, but there is definitely more that kids can learn. Educators want these toolkits. Making them accessible is one thing, but getting the word out to teachers is another. There are 13,800 public school districts in the United States. There is a need for ocean acidification education as a whole for educators, students, and the general public. When creating a toolkit, visuals, presentations, slide decks, defining key vocab, creating energizing and engaging experiments are a must. And when releasing a toolkit, scholarships or funding should be available to educators, which may be important to having more educators use them. From here, the surveys may lead to a future NOAA symposium or a presentation to the Education Council on the findings and how that can benefit the creation or modification of education toolkits and curricula. OAP will publish this work post-review and will continue to release more toolkits for other regions. And then finally, these will be released during the NOAA Back to School initiative and published post-review. Finally, communication is key, and NOAA is communicating in many different ways like we've heard today, from social media to educational outreach. But things change, so we must change with it. By communicating science in a clear and precise way, the public can learn from it to hopefully move us in a better direction for our oceans and climate. I'd like to thank my supervisor Murph, who's on the call, Liz from OAP, Hallie from Sea Grant, and Bruce from NOAA Education for help with the surveys. I'd like to thank Anne for her unwavering support, Camp Harborview for letting me come out and survey their middle schoolers, and finally, to the one who made it all possible. Thank you.
Thanks, Joanna. That was really great. Questions?
Did you notice like a regional discrepancy between children who knew what ocean acidification was?
A regional.
Like, were coastal communities more knowledgeable?
No, so I was even looking at surveys that were baseline surveys for the actual regions of the toolkits where they were released. So in Hawaii, Oregon, and Washington. And even there was a low understanding of ocean acidification in those different regions. But the surveys post giving the toolkits, the knowledge of ocean acidification had increased. So they are important.
Any other question? All right, well, thanks again.
Thank you.
All right. So, Eric, right? Yep.
So hello, my name is Eric Swan, and my project is the impacts of invertebrate community composition on piping plovers, Cardotus melodus, survival between ocean and bayside habitat on Fire Island. My internship was done with the Virginia Tech Shorebird program, and my SBU my internship advisor was Christina Wales, and my SBU faculty advisor was Costigan. So, like I said, my internship was with the VT Shorebird program, and this is just some background on their studies. So Hurricane Sandy struck Fire Island in October 2012, which eroded dunes, overwashed, and breached Fire Island in 3 places. The Army Corps of Engineers closed 2. It left the Smith Point breach open for natural causes, and it is currently closing pretty rapidly. It's pretty small right now. And in response to Hurricane Sandy, the VT Shorebird program began monitoring piping plovers on Fire Island in 2013 to understand the population response to the new nesting and foraging habitat created by Hurricane Sandy. The study continues to this day. Within a few years after Hurricane Sandy, stabilization and habitat restoration projects took place to maintain Fire Island's natural ecosystem and provide piping plovers with a new habitat as Hurricane Sandy altered Fire Island immensely. This makes for a very good study because Hurricane Sandy came in, and then you can see like the natural effects of it on the plovers, and then humans came in and altered the restoration projects, clearing vegetation, and you can see how that's impacting them as well. So you get both sides, which is very unique for a study like this, wildlife study. And this 10-year project investigates the elements of population change, birth, death, immigration, and immigration by comparing plover demography, food availability, and habitat selection. These conservation effects help management understand the habitat types that benefit plovers and inform future plover habitat creation and management. So this is like what a single day of data collection looks like. This study has a dimensional data that actually has backside as well. Top one is the subsite. Every time, all the big sites like Smith Point separated into 8 subsites. Every time you enter a subsite, there's the time in, time out, how many cars, vehicles, dogs you see, and what you're doing at that subsite. The one below that is a nest visit form. Every time you approach a plover nest, it's pretty much what you're doing, what you're looking at, especially if you're going to trap an adult. The time in, time out, all the observations. And the holy grail, the whole thing, the plover banding sheet. Every time you see a plover, touch a plover, goes on there. The bands are all there. And chick bands are also all there. That would be a chick. That would be adult bands. And then just to quickly go through the bands. So for Virginia Tech, the flag is the P0P, the green flag with white font, and then Virginia Tech bands have the orange. And there's different leg positions. There's the upper left, lower, and then the other ones would be below the tarsus, which is the lower left, upper, and the lower left, lower, which is like at the ankle. And then the study area is essentially Fire Island with the 3 main sites being Smith Point County Park, Ribbed Mussels State Park, and the inlets like I mentioned. It's at Smith Point, it's the west end. It's by the nature center when you drive in over the bridge. It's about 1.5 miles. So you get to the beach, and then you also do the other side of the breach. It's Ho Hum Beach, I believe, is where you enter. It's another like 1.5 miles. So they have like 3 miles. And then this is a Google Earth project. I'm not sure how updated it is, but these are all the nests on Smith Point itself. All the little purple houses or plover nests. I threw this in, I'll just read through it quickly just in case people were completely unaware what a piping plover is. So piping plovers are sandy brownish birds with white underparts and a narrow, often broken collar. During the breeding season, they have an orange bill with a black tip, black collar, and a black line on their forehead. Piping plovers forage alone or in small groups, often just their broods, along the shoreline, eating invertebrates such as insect larvae, marine worms, crustaceans, beetles, and other tiny animals, marine animals. Nests are directly on the sand above the high water mark and consist of 4 egg clutches that take about 25 days to hatch and roughly a month for the chicks to be able to fly. There's so many endangered species in Newark, however, the global trend is increasing. And on the right, it's the chicks, fledges, and so now we're kind of, title is motivation, we're kind of shifting into my project, one of the details of what I specifically did. So this project is important to marine conservation because piping plovers are an endangered shorebird species that have survival and productivity rights that are highly correlated with survival suitable wildlife habitat. And foraging suitable wildlife habitat for piping plovers is crucial, making this study on prey abundances of invertebrates in these areas a key component to learning more about the efficient conservation of vital shorebird foraging habitats on Fire Island. And findings from this project can help enable more proper conservation actions and policy decisions for park management, on Smithbourne or on Moses, to help piping plover populations and preserve habitat with high abundances of invertebrate prey. So now kind of switching into the field work I did. When I'm referring to the graphs and such, they have been doing invertebrate sampling before I showed up. It's a long-term study, close one. From 2014 to 2019, and COVID kind of stopped in 2020, 2021. Then 2022, I did most of the field work for invertebrate sampling. And essentially, I'll get to the process later, but these are the kindness keys to figure out which invertebrates are stuck on the food. And then the objectives of this study was to figure out if piping plovers have access to different amounts of invertebrate prey ability between the two habitat sampling areas of ocean and bayside habitat, identify key habitat locations to conserve due to having high abundance of invertebrates, making for good foraging habitat for piping plovers, and aim to discover if broods with greater prey abundances grow faster and have a higher rate of fledging. So this would be what the sheets I would be filling out look like, and the procedure. So the procedure follows a strict SOP, which is a standard operating procedure. It makes it so the sampling from 2014 to now is all done in repeatable fashion and can be compared. The infrared sampling field work was done June to August when piping plover chicks are present. And then the insect traps themselves, it's tanglefoot, which is glue, on two paint stirrers, which is the picture you saw before. And you place one down as glue on just the top of it. You put it on the sand, it's horizontal, and then one stuck in the sand with glue on both sides for bugs to fly into. Vertically. And the traps are left for 30 minutes, and you come back, and then you do the status sheet. We'll just go through one of them, still the same. So you take the sample waypoint, you put it in the GPS with a Garmin GPS unit, and you use a Kestrel, you get the wind speed, wind direction, temperature. You put your geolocation and your habitat. You time in, and then after 30 minutes, you come back, you lift up the stick. So this one, vertical stick had 1 amphipoda on it, and the horizontal had 6 amphipoda, and then 2 types of flies. So to do, it's called interspecies, kind of covered, but a specific R package for indicator species analysis. It was used to study. It's used so you can focus on the statistically significant invertebrates that we were going through on the samples on Fire Island. And my project studied 17 orders of invertebrates. And then the interspecies found that 4 of them were statistically significant for piping plover foraging. And they're listed, starts with Blattotoda on the bottom of the first page. And it's Blattotoda, Phenaciptera, Heteroptera, and Diptera. And then 2 of those 4 indicator species were the most abundant species found in the invertebrate sampling collection, which is a nice finding. And that was the Phenaciptera and the Diptera, the 2 flies. And the Phenaciptera, we found 3,298 individuals. In the Diptera, there's 2,682. This is over the 2014 and now. And then bay versus ocean invertebrate abundance. So there's a box plot that shows the bay side and the ocean side across all the subsites and the sites themselves for the insect traps. And we pretty much just compared them, and we found out that the bay, when it comes to invertebrate prey availability, the BT invert sampling studies show that their bayside habitat provides better foraging for piping plovers on the Fire Island. And this shows invert abundance on Fire Island over the span of the entire sampling process. So the highest invertebrate abundance was present in 2014, which was the first year of the study. And there's no real way to figure out how this is based on my data, but my hypothesis was that Hurricane Sandy provided optimal conditions for invertebrate species to thrive, but those conditions shifted just a year later. Another one could be that predators of bugs were just like wiped out by Hurricane Sandy, so they were higher, and predators kind of slowly came back, and the bugs went away. So abundant sunflower island during pipe and plover breeding season. This is just looking at specifically the months where the plovers are there. So a box plot graph shows the invertebrate abundance at its highest in May, and it gradually decreases as the pipe and plover breeding season continues through August. And these results are most likely due to increased competition among piping plovers and other shorebirds, as immigration of shorebird species to Fire Island increase over the months spanning May to August. Also in May, it's mostly just adults competing for territories and foraging. And now there's chicks in the later months, so more mouse. And then this shows the plover chicks Bay versus ocean compared to invertebrates collected and when they're detected. So when they're resighted, everything's recorded. You can tell if they were resighted on Bay or an ocean side. And then this graph displays a trend line for the chicks seen in ocean and Bay side foraging habitats to easily compare the two habitats. The results show ocean side piping plover chick detection rates have an increasing trend correlated to high invertebrate community compositions, whereas the Bay side habitat is a leveled off trend as chick detections are similar despite changes in the invertebrate community composition. Not really sure why these trend lines are so. I thought they would look the same, but my guess would be there's a lot more ocean. There's probably hot spots where the invertebrates are, so they kind of gather there. Whereas the Bay, not as much bayside habitat, so it's kind of just consistent throughout, so they can kind of feed throughout. They don't have to all fight the same spot. Fire Island habitat conservation. So foraging areas conserved should seek to provide high abundance of Demetrios and Diptera. Those were the two orders that were found to be indicator species and the most abundant on Fire Island. And then identify those locations to conserve for habitat. And policies to protect current or newly created mitigation zones. Mitigation zones where Hurricane Sandy came in, overwashed an area. Over time, vegetation grows, regrows. And if it grows too much, the plovers can't nest there at all. So they come in, and they get rid of the vegetation again. So the plovers can go back there. And this study would help them identify places with a lot of invertebrates so they can clear those areas if needed. They become overgrown. And essentially, what is next? So further analysis linking invertebrate data to pipe plover data regarding growth and survival rates. Unfortunately, COVID wreaked havoc upon the crew housing and set things back. And I didn't get like the second half of the data yet, which was like tying the bugs to the birds. So that's going to continue. And the aim is to discover fruits in areas with greater invert prey abundances grow faster and have a higher rate of fledging. And then hopefully the end goal is to have my final projects published in their VT Shorebird annual report. I believe that is it.
Sarah, questions?
Did you sneak any plovers on?
Yeah, plovers home.
They are so cute.
So I actually work at Robert Moses with the piping plover, so I might have seen you.
Currently?
around there. Yeah.
I've seen the crew a few times, yeah.
So I don't know if you know too much about this. I know you were talking more about food availability, but I know the Army Corps of Engineers recently did a project at the western edge of Fire Island. Yep, where they basically cleared out the dunes to provide, from my understanding, to provide suitable nesting habitat.
Yeah, it's like shorebird habitat, yep.
So from what I've only been doing this for this summer, from what I've seen, it seems like it's a very productive area with numerous different species.
Probably one of the most, yeah, on Long Island, probably, yeah.
I don't know if you know anything about that, but we try to look at Democratic Point the most because that seems like the most.
Yeah, I actually did your job last summer.
Oh, really?
So yeah, I'm very well aware of Democratic Point. It was much more vegetated.
Yeah.
Even last summer, that place changes daily.
Yeah.
And so yeah, I think that restoration project would be a good thing for the shorebirds. There's a skimmer colony there now. That was not there last summer.
Yeah.
Now all of a sudden there's 50 skimmers and chicks there, which is amazing. I mean,
yeah.
Out of nowhere. But yes.
And another question with that. So you're mentioning Bayside versus Oceanside. You might know at Democratic Point there's the Bow Basin and there's a lot of tidal mudflats in that area.
Yeah.
That seems like bird heaven over there. There's tons of different plover species. would that be considered a bayside habitat or?
Bayside was, for our sake, it was, the Democratic Point had some bayside, and then Stockpile was also considered. I'm not sure, I can't remember exactly what the boat basin was, but those are the two places that I did sampling in.
Okay.
Stockpile and Democratic.
Great.
One more thing about science communication, do you know, like, does VTech have any way that they communicate their science publicly throughout the season, or is it sort of wait till the report is complete after the season, then it's published? Because on Long Island, most people know the piping clovers are pretty controversial. There's a lot of angry people.
Close the beaches,
This year,
yeah.
someone actually deflated the tires for your.
And they also stepped on some eggs, it came in fire, yep.
Yeah, there's been a lot of issues with that, so I'm wondering,
First semester,
I've been
actually,
thinking about this, is there a way to sort of release information to the public and, you know, actually give people an idea of why we're closing down the beach for a month or things like that, or is it sort of just wait till the season's done, then publish the paper?
Sure there is. Virginia Tech is just straight researching, so they don't deal with any of that, they don't deal with the public at all. But I'm sure there are ways to do it. They do release their reports at the end of the season though. That's pretty much the only way Virginia Tech would do it. Yeah, it's just straight science.
Great. Okay, well, thanks a lot, Eric. Very nice. Now we have Demetrios talking about the ribbed mussel.
Yeah, sure. How does this sound? Can everyone hear me?
Really captured
Oh, that's funny. It's like, might see around.
Is that what was just turned on when they?
Just turned the captions on, yeah. Somebody asked for it to be turned on, but it looks like they're on, so you're fine.
All right, thanks. That'll be good for my mom. All right, so my name is Demetrios, like Ann mentioned earlier, class president, totally legit, no need to look into that. My project is on bioextraction of Enterococcus using ribbed mussels, Peconics, Denissa, in various spatial arrangements and densities. So before I get into it, I want to lay out what my presentation is going to look like, the plan, why we did this research, why the work is being done, the experiment itself, the results that we found, and some of the broader impacts and implications of the research that and the findings that we found. So the plan is the DEP of New York City is having some issues in Jamaica Bay where basically when there's a CSO or a combined sewage overflow event are the more extreme cases, but just in general, they're having issues with human fecal coliform bacteria entering the water, which is bad for humans as well as the environment. And that will create shellfish closures. Jamaica Bay is just closed to shellfishing totally all year round. And they use the ribbed mussels because they are able to filter down to a specific size, which we'll get into a little bit later on. What a CSO event is, basically our infrastructure when it comes to moving sewer water is not totally up to date and as efficient as it could be. It can handle normal non-precipitation weather events and when water storage is at its least. So things like in the winter and on a nice dry day, the sewers aren't really being too stressed, but on a rainfall event, I believe in New York City, if it rains for 15 minutes or more, it kicks in a sewage overflow event. Where it basically bypasses the treatment plant line that'll bring it to, and it starts going directly into the water untreated. And this happens throughout New York City in various locations. This one in particular we're looking at is Bergen Basin, which is where they want to implement this study in the field, which we'll get to in a little bit later. But the way this plant and this man-made basin are worked out, Jamaica Wastewater Treatment Plant, which has an extremely high density of homes and water that are coming into that treatment plant. At the end of that canal there, the plan is to deploy ribbed mussels here where this red arrow is. And then to the right of that, we have JFK Airport. For those of you who may not be familiar with Long Island and the layout of it is, you can see on that map over there, Where the L on Long Island is, the bottom left of it is where Jamaica Bay is. It's also where the airport is as well. So this is a high density population area where, these issues are just huge, basically. Yeah. This is the graphic made by Hazen Sawyer and the New York City DEP to kind of lay out the entire timeline of this project. This project's been going on for a few years before I came on board with it, and it's going to continue now that my specific contribution with this project is over. Started with microcosm testing, where we're using the rib mussels in beakers. We're testing the physical factors and removal of certain bacteria. Then we bumped that up once these results came in and they were positive. We bumped it up to the mesocosm testing. That's what I did. We'll get into that a little bit later. And then in situ is going to be actually deploying mussels into the field, taking the measurement studies there, making sure that things are continuing on the trend, the positive trend that we've been finding so far with the research. And then it goes into the actual full-scale application of this project in Bergen Basin. And this timeline's been worked out pretty long. We're just finishing up this part here, or just finished it up. And that was slated for a 15-month study. And this total time period goes on to about 8 or 9 years of actual work. So it's a really large project that has been taking place for a few years, having to prove why rib mussels make good animals for this project. Rib mussels opposed to other shellfish because SoMAS Long Island, we have a very marine heritage based culture here in Long Island. Everyone hears about hard clams, everyone hears about oysters. Those are the popular animals, but the reason that we decided, or the DEP decided rib mussels have a good chance at this is because it's been shown that they filter down to the bacterial level, about 1 to 5 microns, more efficiently than other shellfish do at that size. So rib mussels, which also are found in brackish habitats, you'll find them all along Spartina grass beds. If you almost are walking in a Spartina marsh, it's raised up a little bit, and that's a ton of rib mussels within the roots, raise up the actual bed of the marsh a little bit there as well. And another nice thing about this is a green solution. So using marine animals like the rib mussels to combat these sewage overflow events and the bacteria in the water, there aren't really many drawbacks to adding more mussels to an area like Bergen Basin that is not used recreationally at all because of its proximity to JFK. You can't just go swim around in Bergen Basin, nor would you ever want to do that either. So these animals, basically deploying them and allowing them to do what they naturally would do, will give a nice boost to Jamaica Bay, especially in that little area of Bergen Basin there. So running the experiments, the first thing we had to do is we actually have to have the mussels and house them. The first start to that, though, is you need to be able to feed these animals and keep them alive. There's no experiment if there's no mussels. And we operated out of Flax Pond Laboratory, which is about 15 minutes away from campus here. This is in the main shellfish room piece. So if any of you have been to Flax Pond within the last couple months, you may have seen these bags of all different colors. Those are the various species of algae that we were growing. And a lot of maintenance goes into just caring for these algae bags alone. It's called a CCAP system. It's a continuous drip where seawater travels through a pressurizer and a pasteurizer, and a heat exchanger, where the water is sterilized and then dripped into these bags where the algae cultures can grow. In an ideal world, nothing gets into the bag except for the algae, but we don't live in an ideal world. So sometimes bags crash. You have to be able to, keep the food going. So when a bag is showing signs of crashing, another stock culture will be brought up. And those stock cultures are actually here at Stony Brook. And we'll bring them over and we'll inoculate a new bag. We did a little playing around with some things where we did wind up inoculating one bag for another bag, which worked out pretty well and stayed alive for a little while we needed it to be feeding. This was to supplement the feeding that we did. We also did another method of feeding, which I'll get into in the next slide, but this requires steaming of the lines, making sure no bacteria is growing within these actual glass lines here. That's where the algae travels through. And then this is a closed system, so nothing ideally is exchanging with the outside environment. And then you can see that little spray bottle of alcohol there. You use that to sterilize your hands before actually handling or dosing, which is adding nutrients to feed the algae itself. Now, on the opposite side of that tank there, you will see the actual ribbed mussel holding tanks. We had 2 tanks that were started at about 10 degrees Celsius when we first collected the mussels, and then as we moved into the experimental phase, we wound up raising them a degree a day to get them to the experimental temperature, which is about 25 Celsius. Now, these 2 tanks, we have our water manifold, which would take the water at the head of the tank there and then transport it throughout the entire tank. This was to help keep the water moving as well as any food that was going in. The other method of feeding I mentioned is this bucket here. We submerge it in the water in the warmer months, and in the cooler months, we could actually just keep it right on the wood there. But that has 2 peristaltic pumps that run rubber tubing up and over and then into the tank itself. So we had 2 forms of feeding going on. Because once we got into the experimental temperature, which is a lot warmer, the metabolic demands of the ribbed mussels was significantly higher than it was when we first got them. And we were struggling to keep up with them feeding. For example, I would fill that bag, dose it, take a bucket of algae, dump it in, and then actually rinse out the algae paste graduated cylinder into the tank. The tank water would get completely dark with the algae, and about 15 minutes later, it was crystal clear. So these things were feeding at an extremely high rate. That's just because of the warmer temperature we were holding them at. Then cleaning, twice a week, we would drain down the tanks, give it a really good hose down, hose off the individual pots that the ribbed mussels were being held in. You can see there. That was to prevent any mucus that might be forming or whatever might be going on. This water, we did filter it through a 5 micron bag when we were using it in the storage tanks and moving it into our holding tanks. But still, it's seawater. It's coming right from Flax Pond. Nothing's ever perfect. So we wanted to make sure that the water was clean and good for the animals to be living in while we were holding them. Now, the experiment itself, the actual design of these tanks, it's 3 separate tanks. It's the large mesocosm experimental tank, which you can see in that lovely graphic on the right there, but this is what they look like anyways. And then at the head of those tanks, there was what was called the head tank, which is where water was stored in, usually the day before, to bring it up to the experimental temperature we wanted at. And then the sump tank at the bottom here is as water traveled down, it would be triggering a float switch on a pump there that would move it back up to the head tank, and that was almost creating a loop there. We had to design the tank so that the water flowed pretty steadily throughout the tank uniformly. You didn't want it, for the purpose of this experiment, to show the absorption. You don't want water kind of dragging on the side and eddying and creating pools along the side, so you want it to be a nice uniform flow throughout the tank. We did that so by creating the manifold system at the front where there's holes drilled into PVC that kind of uniformly distributes it through the actual tank itself. Now, you might notice that there is a lot of water being used in this. For those of you who are doing research at Flax Pond or have been to Flax Pond, there is no seawater in the building. So we had to run a 3 horsepower pump and about 600 feet of line down into Flax Pond itself to get fresh, to get the seawater and store it in our 800-gallon tanks. And we did this from when I joined on the project in about November, December, and then up until its conclusion in May. And then, sometimes the pipe freezes, and I called Matt, and Matt said, all right, get out there and clear the pipe. And I really wish I got a picture of this, but when it's January and you're trudging out into the marsh and Flax Pond and shoving your hand in the pipe, the last thing you think about is taking a picture in that water. But just part of the hangups of running any experiment, you have to be able to deal with the punches. You can't just not have the water for the ribbed mussels, so you have to be able to diagnose whatever problem that is. Eventually, we got the line cleared, and we were able to get the water. Now, when we ran the actual experiments, just so you could get a little bit better of a view, these are the head tanks here. This is where the rib mussels are being held in the water. The influent and effluent, which is where the water is entering and where the water is exiting the experimental tank. That is where we took 3 samples when we would send them off to the labs, or we would use them here in Stony Brook, which I'll explain in a little bit. But the influent basically is coming at the front of the tank here and here. And then the effluents here where there's little drains that the water can pour into. And that is to show that as the water is traveling through the experimental tank, where the bacteria is being added, which is the head tank, so the highest concentration of bacteria is going to be found, hopefully, at the head of the tank. And then as it travels through the experimental tank, moving through the rib mussels, which are all hopefully feeding at that point, percentage and clearance will show up when you're taking the samples at the effluent point, and you should see less bacteria where the water is exiting the tank. So that's what we were doing with that. These pumps here, this is to control the flow, so we knew exactly how much water was going into the tank, about 16 gallons per minute. And then as that's going, it allowed for a nice, easy flow through there. Now, you'll see here, we'll go for this one actually, yeah. So the way we analyzed whether or not the bacteria is coming through the tank well was using the flow cytometer in Dr. Bas Malong's lab. He explained this to me very nicely that I can explain it to you guys now. The flow cytometer basically is detecting any particles in the water as it's traveling through. So we'll use a blank that we took at the beginning before bacteria was entered to clear it. And then we have the ability to detect the concentration of bacteria at the beginning, head tank, and then at the end. And the way it works is you see that circle there with all those green dots in there. The Enterococcus that was used to run the experiment had a biomarker on it that basically showed up green on these plots here. And then any other particles that may be found in the seawater are coming up in that darker coloration on the bottom there. So it makes it very clear to us when we're testing and looking at the flow cytometer, we can say, okay, here's the Enterococcus, this is its concentration, this sample, and all this other stuff isn't really what we're looking for. This is whatever's in the seawater at the time. To be able to manipulate the experiments, we ran 6 different levels of density and spatial arrangement. We hung the rib mussels in these yellow mesh bags, and using those yellow mesh bags and hog rings, we were able to manipulate the rib mussels where they stood in the water column, because we were finding when we first started filling these bags, they would all sink to the bottom. They wouldn't stay nice and stacked on top of each other. So by squeezing at certain points of the mesh, we allowed to have them uniform throughout the actual water column themselves. This way they weren't all just stacked at the bottom, and then any water that passes over the top of them isn't being filtered by them, like in theory. But the first 2 trials we did were density based. We did 720 rib mussels, and then for 4 trials, and then we did 1,440 mussels for 3 trials. That was to show the difference between the densities. And then the next 4 steps were to mimic any, thank you, man. Any, basically environmental factors that they would face out in the field living in Bergen Basin. So bacteria pulse, plus the fresh water, plus the different spatial arrangements, and unfiltered basically kind of works its way into, all right, the bacteria is being entered in, what's going to happen? What's going to happen when the bacteria is entered with the fresh water, and so on. So these are the net results of our percent reduction throughout the study. As you can see, may not be a surprise to anyone, more rib mussels cleared more bacteria, and the DEP put out a threshold of about 10% reduction. That's what their goal target was. Like, we would like to see this reduction take place throughout the experiments, and all the trials exceeded that 10% reduction goal. So the data is actually supporting that it could work out very well in the field. So the next step is going to have to prove that it's going to continue along with that. And rib mussels, what this broader impacts of this study really showed is that, rib mussels are unique shellfish on Long Island because they're not really an edible species. People don't go to the restaurant and order rib mussels for a couple of different reasons. If you've ever eaten a rib mussel, you probably found out those reasons yourself. They do a really nice job of building living shorelines. They tangle in with, they have a nice symbiotic relationship with Spartina grass, building up these nice shorelines that have a multitude of ecosystem services like protecting the shoreline, habitat for juvenile species, and filtering the water not only for bacteria. That is an issue that faces all throughout Long Island. There's a lot of different areas, bays that are closed to shellfishing and are considered uncertified water bodies by the DEC. But it also can keep down other issues like algae blooms and other water quality based issues that we face here on Long Island. And then acknowledgements and any questions you guys may have.
No questions till lunch, because we got 2 more talks left to go, and one is coming from south of the border, so we don't want to make Isabella wait too long. Hopefully she's still connected. But thank you. Really interesting project. Great. So we have Michael, fishing history of catch reporting. Excellent title.
Always likes some good puns. But I'd like to thank Dr. Yang Chen for being my mentor on the project, as well as Rachel Sizak at the DEC for helping me out with acquiring the data. But historically, fisheries management has focused more on the commercial sector. And this is an issue as recreational fisheries. Oh. Uh-oh. All right, there we go. Nice, short and sweet, right?
You can have a little more time.
All right, that's my overview. All right, yeah, but historically, fisheries management has focused more on managing commercial fisheries rather than recreational ones. And this is an issue as recreational fisheries have been increasing in importance. And this is largely due to an increased number of participants lately with recreational fisheries, where some recreational fisheries like the striped bass fishery in New York are larger than the commercial ones. But recreational fisheries also have substantial impacts on local communities and the surrounding economies, with anglers spending money on, gas for the trip, bait at tackle shops, or even snacks at local convenience stores. But this implies that managing these recreational fisheries is more important than ever, but typically management hasn't been great, and there's a huge lack of good data quality on recreational fisheries. But regulations are informed by NOAA Fisheries, who collects data with the Marine Recreational Information Program, and they do this mainly through surveys. There's a mail-in survey and the Access Point Angler Intercept Survey. I'll refer to that as APIS for the rest of the presentation, but another way to get data is through vessel trip reporting for hire vessels. These are party and charter vessels who also make up the recreational fishery. And the vessel trip reporting is mandatory, but there is frequent non-compliance. And generally, the data quality is very poor, as the VTR data is not accurate and the reporting is mostly incomplete. But this summer I worked with the APIS program as a field interviewer. So I got to work at marinas, boat ramps, and piers. So my summer was awful. But yeah, I'd be assigned to a site and I would go and survey recreational anglers who are done fishing for that day. And just pretty much the questions were designed to estimate fishing pressure and effort. And then also I would ask them, if they caught anything that day, try to measure and weigh their catch to get some catch data as well. But I would also be assigned to go on headboats and conduct the survey at sea. On those trips, I would mainly focus on discards data, which is fish that are caught but don't plan to be kept. So that could be short fish or non-target species. And usually those were pretty fun. But overall, most anglers were very happy to do the survey. And others, of course, not so much, because I was a state employee. But then moving on to my actual project this summer, I evaluated New York's for-hire industry vessel trip reporting in 2010 through 2011 to examine possible trends in the data. And because this data set was so large, I did decide to focus on 2 species, which were striped bass and summer flounder. For people who don't know what summer flounder is, it's fluke. But yeah, I chose these species due to their recreational importance and overall better data quality than some other species. And the goal was to examine the quality of recreational fisheries data and provide recommendations to improve this data. And the VTR data was confidential, and I had to request access through the Atlantic Coastal Cooperative Statistics Program and the DEC to obtain these reports. So I obtained over 64,000 reports from 2010 through 2020. And first I looked at the total number of the total data set, and I separated it into reported catch, which is landings and discards, and then just reported landings. And you can see pretty obviously, most reports were in 2010 and 2011, followed by a steep drop off in 2012, and then a slight increase all the way till 2020. This steep drop off was most likely a result of Hurricane Sandy, or Superstorm Sandy, sorry, that rendered many vessels unable to fish throughout 2012 and the 2013 season. But then next I looked at the VTR reports by county. So for both species, the highest number of reports was in Suffolk County, and this could be due to just more vessels fishing out of Suffolk County, and then the second highest was Kings County. Again, we see the same trend with high reporting in 2010 and 2011. Striped bass did increase pretty greatly after 2016, which may be, it could indicate higher compliance, but it does not account for vessels entering the fishery or, there's more people caring to report catching the species. When looking at summer flounder, it tells a slightly different story with an actual decrease in landing reports. And this could be due to a number of things. Again, it could suggest a decrease in compliance, but more likely, during this period, there were more restrictive regulations on the species, which provided less incentive for these vessels to take directed trips for. But then I compared the VTR landings to the Marine Recreational Information Program estimated landings. So the MREP landings are comprised of data I collected the APIS survey, and then also VTR reports by for-hire captains. And I just want to examine the overall trends in the data. So the blue is the VTR landings, and the orange is the MREP landings. And I just wanted to see if the trends kind of followed, like the VTR trends or the MREP trends followed some of the VTR data. But interestingly, when I looked at the 2010-2011, there was more fish being reported by VTR, and it comprised more of the MREP data itself. So interestingly for summer flounder, the VTR landings were actually more than the MREP landings, which makes no sense because why would MREP include those landings into the data? But then that got me interested, and I looked into the date of reporting compared to the trip end date. And it was pretty obvious to see that many of these vessels were reporting 5, 6, 7 years after their trips. But yeah, I took the trip end date and then the date of reporting, and you'll notice this graph is plotted on a lot of scale. So the highest number of days taken to report occurred in 2010 for both species, and they're both over 1,800 days, which is about 5 years. And then 2011, it decreased slightly to 1,000 days, which is about 2 3/4 years. But then the lowest number of days for both species was in 2020, where striped bass was only about 4.5 days, and summer flounder was less than half a day. So that was definitely very interesting. But then overall, there was low compliance throughout the entire data series, but there was high compliance before 2012, and this was mostly due to late reporting. So this is because, again, of Superstorm Sandy that rendered vessels unable to fish. And then later there was relief funds distributed to these vessels, and these vessels would have to apply for them through the DEC, and you have to prove that you had at least $5,000 in lost revenue and over $15,000 in annual earnings from an eligible fishing sector, and an obvious sector is for hire. And one way they could do this was through vessel trip reports. So you had a lot of captains kind of scrambling to report years later to try to get their fair share of relief funds. But interestingly, there was no decrease in reports during 2020 as a result of the COVID-19 pandemic. So that might suggest that some of these captains learned their lesson, possibly not. But how do we improve compliance in trip reports? And while VTR reporting is mandatory, many vessels still fail to comply, and there are no repercussions for not complying with the trip reports. So I think the VTR needs to be incentivized, or there has to be some sort of enforcement to increase the number of trip reports and to get more accurate data, because again, more accurate data on these fisheries will lead to more effective management and more sustainable fishing. But a few more recommendations on improving recreational fisheries data. One would be to improve the APIS program. So the MRIP is still constantly making slight improvements to it, but simply just having more interviewers in the field would be able to collect more data and then have better data quality overall. And there are also recreational programs where anglers could self-report their catch. And this could be a good start, but it's kind of a little here, a little there. Not everyone's going to report their catch. But then improving VTR compliance. So Cornell Cooperative Extension has a electronic vessel trip reporting program where they go around and teach commercial fishers how to use electronic reporting, which makes it really easy. They can do it right before they get back to dock. And this would be easily transferable to recreational fisheries, especially on like some of the larger head boats like Captree and out in Montauk, where captains could easily, right before they get back, punch in what they caught today, what they threw back today, and they didn't have to worry about it. It was funny, one of the boats I went on this past weekend, they were late coming back to dock because he forgot to submit his BTR. So he was like in the Captree boat base and just really quickly punching it. But another thing is, even if the vessel trip reports do increase, I've been on some head boats where the crew is usually in charge of keeping count. And if it's like a porgy trip where anglers are keeping, 15, 20 fish each, they don't keep accurate counts. They'll kind of estimate, and they rarely actually keep discard counts. So I think an outreach and education program for those, vessels and crew would be very beneficial, just to educate the importance of keeping accurate counts and accurate reporting of VTR, because it ultimately will help them, because this is their livelihood. But yeah, thank you.
Can you go back to the slide with like the days?
The number of days?
Yeah. So 2020 was 4.5 days.
Yeah.
And it was as high as 2019. Do you know how?
No,
many
because
days
it's a log scale.
What?
It's plotted on a log scale.
Okay.
So you'll see that it doesn't look that different, but 2010, 2011 is over 1,000 days each. But yeah. Yes.
So were these vessels without like fisheries observers out there?
So I'm not sure about the charter vessels, but for head boats, members of the APIS program or the APIS survey will be assigned to go on them, and we'll try to do the survey and stuff like that. So we're kind of the observer on that boat. Charter vessels, we can't go at sea, but we'll interview anglers who fish on them that day if they, of course, we're at the site and finish fishing for that day. But yes.
So do you have
different recommended counting methods because counting by hand seems to be inaccurate. There's just too many fish to count accurately. Do you have like a camera on the boats or some kind of program that you can take and put it to some kind of tool that counts more of them?
I think the camera would be a very good idea. I know a lot of captains would hate that idea. Because of course, you know, some captains, people are paying to go aboard these vessels. They do feel obligated to keep fish. And if it's a fluke trip or a summer flounder trip, the size limit is 18.5 inches. And I've been on boats where people are begging the captain to keep 16, 17-inch fish. And whether or not they do it, I won't comment, but they don't want cameras on their boats.
Yeah.
Yeah. But yeah.
Backfire. Great, well, thanks again, Mike.
Thank you.
So last but certainly not least, we have Isabella coming from Costa Rica. If I can get her here. Let's see. There you are. Great. Your co-host. All right, so you can take the screen. Say something so we can make sure we hear you.
Can you hear me?
Yes.
Okay. So. Right. So hi everybody, I'm Isabella and my project is vegetation type and sand temperature influences nest size selection of the Pacific green turtle at Playa Rio Oro in the Osa Peninsula of Costa Rica. So what we're gonna talk about is introduction, study site, methods, results, and discussion and future recommendations. So I want to talk a little bit about why this species and why Costa Rica. So the Pacific green turtle is an endangered species. It has a decreasing population trend. It is considered a subpopulation of the green turtle from the Atlantic. And for many years, scientists believe that they are a different species because of many differences in morphology, geographic differences, and reproductive differences, but DNA and genetic testing shows that they are the same species. So the subpopulation in the Pacific, we don't really know a lot about them, and they are known as black turtles because they're darkened in color. They have primary nesting grounds in Mexico and Ecuador in the Galapagos, and secondary nesting grounds throughout Central America, so Costa Rica. And why Costa Rica? So climate change is a global issue, and the Intergovernmental Panel on Climate Change, the IPCC, identified Costa Rica as a vulnerable region. So it is a hot spot where weather conditions are going to change in the next 50 years. During the wet season, the temperature is going to increase from 1 to 6 Celsius degrees, and during the dry and wet season as well. And climate change has many impacts on sea turtles. Sea turtles are affected by many different things, but I'm just going to talk about climate change. So most of us have heard that warmer temperatures produce female hatchlings and cooler temperatures produce male hatchlings. And this is a problem, especially for the future of the population as a whole. The ratio is really skewed towards females. But we also know that it affects hatching fitness and hatching success. Why? Because when we have warmer temperatures in the sand, so in the nest, the incubation period is shorter. And so these hatchlings are smaller and weaker. They have high residual energy, meaning less yolk was converted into functional tissue. While when we have cooler temperatures, the incubation period is longer. So these hatchlings are larger and stronger. They have low residual energy, meaning more yolk was converted into functional tissue. And so these hatchlings are are stronger and they can avoid predators faster. They can swim faster because once the hatchling reaches the ocean, they swim for like 3 days nonstop trying to get out of this dangerous zone. And so this is really important. Not only does it determine the sex, but it affects the whole population. And then you also have the extreme temperatures that can just literally cook the eggs. And so sometimes you do an exhumation of a nest and then you just find cooked eggs. So this can happen as well. And so nest size selection is the fact that females lay their nest in zones that are not randomly chosen. And by this, they can somehow combat the effects of climate change, such as the increase in temperature. So for green turtles, including Pacific green turtles, we know that they like to nest near the vegetation, near this line. I hope you can see my pointer. So they like to nest right here. And we know this for a few years. However, we do not know exactly which role does vegetation play. Is it like the shading? Is it the root system? We do not know exactly. And so for the study side, so in Costa Rica, I came as a research assistant. This is an internship with COPROT, which is a community-driven turtle conservation project that's been around since 2018. And so we have permits to patrol like almost 10 kilometers of beach, but right now we're just doing this beach, Rio Oro and Pejeperro. And this study was only focused on Rio Oro Beach. And here in this part of Costa Rica, which is right here, this is called the Osa Peninsula, and then it's the Southern Pacific all the way down here. So right here, we get olive red leaves. We have a really stable population of olive red leaves. Last season, we had almost 7,000 nests. And we, through COPROT's work, we have been able to determine that we have an important population for Pacific green turtles. Last year, we had almost 400 nests. So we have been able to determine this through the collection of data since 2018, because we didn't know about it. And this part right here, this is the Corcovado National Park. And then this is the Rio Oro Wildlife Refuge. So it's super protected. You don't have tourists coming here to the beach. I mean, you cannot really go to the ocean here, but it's really protected. However, we do have poaching and some motorcycles on the beach, but there's no besides that, there's no more threats and climate change, of course. So for the methods, the purpose of my study was to determine a potential relationship between vegetation characteristics of Rio Oro Beach and nest size selection of Grand Pacific. So like I mentioned, we know that vegetation plays a role. However, we do not know exactly which is the role. And so I believe that understanding the vegetation type of this beach in particular and the role it can have in sand temperature is an important step to design effective conservation measurements, such as reforestation programs. So I'm gonna talk about how we did my study. I'm gonna talk about beach coverage, nesting data collection, vegetation coverage, and the temperature measurements. So for beach coverage, this is Rio Oro Beach right here. For data collection purposes and relocation purposes, we divide the beach into 3 zones. So zone 1 is under high tide line. Zone 2 is between the high tide line and the vegetation line. And then zone 3, it's right within or behind live vegetation. And we also divide the beach into sectors. So we have like numbers every 25 meters in a sequential order. And this helps us locate the nest and come back and do exhumations when the hatchlings emerge and for spatial distribution of nests. And so from data collected for the last season, 2021-2022, this is all the number of nests in the different sectors that I just mentioned. And we're just talking about the Rio Oro Beach, which is 2.5 kilometers, by the way. And so we see this big peak over here where they're nesting the most in these sectors right here. And so I use this to determine where to put the temperature loggers that I'm gonna talk about in a little. And so just for reference, this sector is like from around 72 to 69. So this is where I focus my study. And from data collected, we know in this area and literature, we know that green turtles like to nest by the vegetation, which is considered zone 3. So last season, we had, like I mentioned, almost 400 nests, and 238 of those nests were by the vegetation. So we do know that they're doing that in this area. And so I took all the data for Pacific green turtles nesting for last season, and I plotted it into GIS. And this allowed me to like see the density. And so, like I said, I focus my study in this area right here. And you can see, so you can see that this is where we have a line of vegetation. And then we don't have really a lot of nesting where there's no vegetation. So even just from an image, you can already see that difference. And so to determine the relationship between vegetation type, coverage, and nesting activity, I categorized the vegetation into 3 different categories. So we have the old forest border, which is tall palms. So the leaves are starting above 1.5 meters. They're adult palms. Then we have the young forest border. You can see you have young palms. The leaves are starting at less than 1.5 meters. And then you have open sand or beach grass. And we're just talking about this like border right here between the sand and the vegetation. So that's where turtles are nesting. They don't really go like 2-3 meters behind the vegetation. They nest like in this turtle border. And so for temperature measurements, I wanted to see how this different vegetation types, if it has an effect on temperature, sand temperature, because the eggs are laid in a nest. So what I did is I put 6 data loggers that look like this. I programmed them to record temperature every hour for 20 days. And we placed them in a 50 centimeter deep hole in the sand. We couldn't do it on real nest because this is not the season for Pacific green turtles. The high season is December, January, and February. And so it was just not possible. But we did get interesting results, even though it was not like a real nest. So for sand temperature, for the old forest border, so the tall palms, the mean sand temperature was 26.3 Celsius degrees. And this red line is just showing that average temperature. For young forest border, the mean sand temperature was 27 Celsius degrees. So we already see almost a degree in difference. And then for open sand grass, the mean temperature, sand temperature was 28 Celsius degrees. So almost 2 Celsius degrees above the other category. And so I did a statistical analysis, a t-test, and I found that there is a significant difference between treatments in sand temperature. So old forest border versus young forest, old forest border versus open sand grass, and young forest border versus open sand grass. And the significant difference pretty much means that these results that I obtain are most likely not due to chance or sampling error. So there is a measurable difference. And so just here, these are the mean temperatures that I just mentioned you, and just to like have a picture of how this different type of vegetation do have an effect on the sand temperature. And for vegetation categories, like I told you, the sectors that I focused on, if we look at the categories, there are 11 out of the 13 subsectors of the beach are considered all forest border. So there is vegetation type and category that they are nesting the most. And so discussion and future recommendations. So through CoPro's work, we have been able to determine that these are important nesting grounds for the Pacific green turtle. And I was able to find that specifically they like to nest where there's tall palms, and that these tall palms do provide shading that have an effect on sand temperature. And maybe this serves as a cue for female turtles that come up to lay their nest, and that's how they're choosing where to nest. Because some other studies, even here at CoPro, have like categories like vegetation, open sand, and just that, but we didn't really know, do they like tall palms, do they like small trees, do they like the grass? So this is an important study for this area, because every beach around the world is different. So we need to know exactly how to approach our local problems to design the best strategies. And so, like I mentioned, I found significant differences in just a short amount of distance, only 2.5 kilometers. And so we now want to do this study on the other beach, which is less vegetated. And we want to use this data to push for a reforestation program. And so we have to show this data to the environmental agencies in Costa Rica, so the CNAC, for them to approve it. But now we have like supporting data that yes, they like to nest in the vegetation, but they also like to nest when where there's tall palms. So this is important because it is important to consider the type and the size of the vegetation that you're going to use for our revegetation program. And by doing this in this beach, we increase the suitability of this nesting area, and we contribute to the conservation of this endangered species. And I would like to thank my great advisor, Dr. David Taylor, Anne and Bob. Special thanks to the CoPro team for all their help and support. And I just wanted to mention that funding for the temperature data loggers was provided by the Latin American and Caribbean Studies Center. And yep, that's it.
Thank you, Isabella. Any questions?
You want to use the microphone?
I don't know. Let's see if that works.
So I assume that the turtles, I don't think it's on.
There we go.
Oh, yeah.
I turned it
I
on.
assume that the turtles don't wander back and forth until they find the older vegetation, that they go straight from the water to it. So what do you think the turtles are using as a cue for where to come out of the water?
So they use sand texture, and once they come out and they start digging to make a nest, there could be a root system or no roots at all. So they're using these types of things to differentiate. Also sand temperature, because I just show you that it has an effect on sand temperature. And I was gonna mention something else. And so they do a lot of false crawls. So they come, especially green turtles, they come out, they start digging, they don't like it, and they go back to the water, and then they come up further, 10 meters like further the beach. And so they do a lot of false crawling because they're really picky where they nest. You don't see this with the olive ridleys. The olive ridleys just nest anywhere, and it's really bad because we have to relocate a lot of their nest.
Any other questions? Okay, well, before I thank you all, I just want to reiterate there is lunch over in Challenger in the what used to be basic. Of course, none of you know that. Gordon knows it, we can follow him, but immediately preceding, and I hope you all stay around for lunch because it's a great opportunity to talk. But Carl had another question.
I just have a comment generally. I've been coming to these things for a bunch of years, and I think this is the most substantive, the best of all of these. I think that, you know, all the work has been like really digging into some real topics, and the students obviously are having more of an experience of forward direction and getting some good work and some good jobs. So I'm very encouraged by the progress from the beginning of this program, which wasn't very good until now, which, you know, usually I would never want to come, and then I would come and just do email the whole time, and I've had my computer closed. So that says something for my impression today.
Thanks, Carl, and I totally agree. You guys impressed me from the start, and it was really nice to see how well all these projects came together. You all gave excellent presentations, so you got the science communication thing, and obviously I think you got a lot out of your project, so that's great. So
Doubly as good.
well, it will be doubly as long, that's for sure.
Especially the grammar.
Yeah, but
No pressure.
no pressure. But you got big shoes to follow in, or sneakers, or sandals, whatever. But thank you all for coming and for presenting, and let's go lunch.